Welcome to the untamed depths, where we let our imaginations wander through the hidden corners of history, science, and possibility. Tonight, we'll all drift into a world transformed by fire and shadow, a world where volcanoes do not erupt in isolation, but together, reshaping the earth in a storm of ash and silence. Close your eyes for a moment and picture it. Mountains trembling, the ground splitting open, and fire bursting into the skies. Not just one volcano, but many an unrelenting chain of eruptions spewing endless clouds of ash that spread across oceans and continents. The sun, once golden and familiar, becomes dim and ghostly behind a heavy shroud. Days turn to twilight. Crops wither. Cities fall quiet. And the earth itself feels unfamiliar, cloaked in a darkness that stretches on and on. This is not just destruction, it's transformation. History shows us glimpses of what even a single massive eruption can do. Frozen harvests, starving populations, skies painted in strange colors. But what if those events multiplied 100-fold? What would happen to nature, to human survival, to the delicate balance of life itself, if the planet were swallowed by ash? Tonight, we'll explore that question slowly, layer by layer. You don't need to do anything but listen. Let the steady flow of this story carry you, like drifting embers in a silent sky. As always, I invite you to share your local time and where you're re-listening from in the comments. It as a way of reminding us that no matter how dark the story becomes, we're all here together. So settle in, breathe deeply, and let us step into a world reborn in fire and shadow, where the earth itself becomes the stage, and ash is the curtain that falls over all. The first tremor strikes before dawn, a low rumble that shudders through bedrock and sets loose dust from kitchen shelves. In villages 1,000 kilometers away, clocks pause mid-tick, dogs lift their heads, and the horizon begins to glow with a faint, unnatural light. It is the moment when Earth exhales molten rock and ash, and the sky becomes a furnace of billowing smoke. Within minutes, the volcanic column soars tens of kilometers, penetrating the troposphere and thrusting fine particles and sulfur gases into the heavens. Lightning arcs through the ash cloud, each flash electrifying the plume's edge, igniting incandescent bolts that dance for seconds before vanishing into the gray pall. By midday, the sun is a pale disk, a ghostly eye peering through layers of ash and aerosol. Its rays arrive at the surface filtered and feeble, casting everything beneath in wan, leaden light. Streets once vibrant with traffic are now empty corridors of muted color, as if a cosmic dimmer switch has been twisted nearly to zero. In cities, entire skylines blur behind curtains of ash, so thick that street lamps flicker on in broad daylight. Architects describe the effect as solar occlusion, but to those on the ground, it feels like the world is turning inside out, as though nighttime has swallowed the day whole. Soon, the ash begins to fall. At first, it is barely perceptible, a fine grit on eyelashes, a whisper of dust on the wind. Then the falling becomes steady, like the softest snowfall imaginable. Each flake is razor sharp, shards of volcanic glass and pulverized rock, fragments smaller than a grain of sand, yet capable of cutting the throat if inhaled. Roofs gather a gray blanket that grows heavier by the hour, bending awnings and gutters under its weight. In parks, benches disappear beneath drifted mounds of ash. Playgrounds turn into ghostly tableaux of swings and slides half buried in powder. Wildlife flees or buries itself. Birds, blinded by the dim sky and choking air, hunker in bare branches. Squirrels vanish into hollow trunks. Foxes patrol empty streets in search of food, their paws leaving ghost prints that quickly vanish under fresh ash. Silence descends with the ash. The usual cacophony of urban life, honking horns, human chatter, the distant drone of airplanes fades to nothing. Sound waves are absorbed by the heavy aerosol layer. Even high-frequency noises fail to carry through the dense air. In towns, windows keep out the grit, but do little to muffle the hush that settles in like a shroud. People speak in hushed tones, fearing that any sudden noise might collapse a roof bowed under volcanic burden. In the countryside, the breeze that once rustled fields of wheat is stilled, as though the land itself holds its breath against the choking rain of ash. The air quality plummets. Portable sensors show particulate matter spiking far beyond safe limits. Masks and improvised scarves become lifelines. Families wrap cloth around faces to avoid inhalation. In hospitals, wards fill with patients suffering from respiratory distress, wheezing children, asthmatic elders, farmers clutching at lungs straining to draw breath. Eyes smart in water, and an acrid taste of sulfur lingers in every mouthful of air. Even those sheltered indoors feel the ash's invasion, tracking grit in on boots and clothing, turning floors into gray carpets that must be swept or shaken out like sodden towels. Forests fare no better. Needles and leaves collect ash in a thick layer that blocks stomata, the tiny pores through which plants exchange gases stifling photosynthesis. Branches sag under the added weight, and small twigs snap off, littering the forest floor. Insects lose the ability to fly. Their wings coated in ash, they tumble to the ground. Predators that rely on them for food go hungry. Within days, entire understories die back, and once green canopies take on a ghostly hue, the vibrant hues of leaves replaced by shades of gray and black. Rivers and lakes become coffee-colored. As ash washes into waterways, it dissolves partially, releasing nutrients and trace metals, but also clogging gills and suffocating aquatic life. Fish float to the surface dead. Insects that emerge from larvae in water no longer can swim. Communities that depend on these water sources for drinking and irrigation find wells choked with sediment, pumps strain to move the thick slurry. Filters clog within minutes. Emergency measures boiling, filtering through fabric, adding flocculants help, but cannot keep pace with the relentless influx of ash. In cities, traffic grinds to a halt. Engines stall when intakes fill with ash. Tires spin futilely on slick, gravel-like surfaces. Public transportation shuts down as visibility drops to a few meters. Electricity falters when ash seizes transformers and clogs cooling systems. In some regions, power plants must reduce output to prevent damage, leaving neighborhoods in darkness. The hum of generators and air conditioners gives way to an eerie quiet. Even reliance on technology becomes tenuous as ash infiltrates every moving part. Yet life persists. Taxi drivers who once roamed full streets now patrol empty avenues, delivering indispensable supplies, food, spare filters, masks to those trapped at home. Firefighters stand ready, not for flames, but for collapsing roofs. Municipal crews race to clear ash from critical infrastructure airports, hospitals, water treatment plants using conveyor belts, and high-capacity vacuum trucks. Volunteers don hazmat suits to venture into worst-hit areas, helping elderly residents and disabled neighbors to evacuate or secure their homes. Children, when they venture outside, look up in wonder at the strangely colored sky. They make silhouettes hands with splayed fingers against the dim light, marveling at the otherworldly glow. In the cracks of broken pavement, weeds press through the ash, their green tipped with white. Pockets of life stubbornly push upward, as if to defy the choking pall overhead. Solitude and reflection follow tight on the heels of destruction. With infrastructure under siege, society momentarily reverts to basics. Families huddle around battery-powered lanterns, telling stories or reading by candlelight. Radios hum with updates on ash dispersal and safety advisories. Scientists interpret satellite images and atmospheric data to predict when the ash will clear. Estimates vary from weeks to months, depending on eruption magnitude and prevailing winds. Media reports document the stories of resilience. A grocery store manager distributing extra masks. A farmer using snowplow blades to clear ash from barns. A nurse sacrificing sleep to tend to the growing influx of patients. Underneath it all runs the reminder of the planetary scale of this event. Debris injected high into the stratosphere can linger for years, spreading across hemispheres. Sulfur dioxide converts to sulfate aerosols that reflect sunlight, triggering global cooling that might extend the dimming beyond the immediate ashfall. Historical records of the 1815 Tambora eruption describe frost in June, snow in July, and famine on continents far removed from the volcano itself. Modern analogs, Pinatubo in 1991, show that surface temperatures can drop by over half a degree Celsius for up to 3 years after an eruption of sufficient scale. In that knowledge lies both awe and dread. The immediate impact of volcanic ash is a theater of sensory extremes, sight reduced to gray, sound muted to silence, taste and smell dominated by sulfur and grit. Yet beyond the sensory, there is a deeper resonance, a reminder that beneath the mantle, S-pressure in the planet's surface, lies a force capable of pausing civilization in its rush. Against the falling ash, human ingenuity rallies. Masks are sewn, roofs cleared, power restored, and hope sustained. When the wind finally shifts and the first pale glimmers of sunlight break through the thinning clouds, people step into a world transformed. Streets dusted in inch-deep ash resemble lunar landscapes. Tree trunks are banded like cake layers, each striation recording hours of fallout. Cars roll through wet ash, creating rivers of gray sludge that must be scrubbed before rust claims metal. In the aftermath, cleanup becomes a monumental task. Hundreds of thousands of tons of ash collected, trucked, and safely disposed of, lest it choke the water supply or ignite in dry fields. And yet, as the skies clear and the ash settles, the resilience of both nature and society shows itself again. Grasses grow through the ash-rich soils, drawing on the minerals deposited by the eruption. Farmers find that in the long run, the volcanic soils yield abundant crops once the immediate danger is past. Scientists study the event to improve predictions and preparedness. Engineers redesign intake filters. Emergency response plans are updated. Communities forge bonds in adversity, their shared experience of silence and gray dawn, forging new narratives of solidarity. In those first days of dimmed skies and falling ash, the world learned afresh of both its vulnerability and its capacity to endure. The eruption's immediate impact skies darkening to gray, ash blanketing every surface like snow, and silence settling over human and wild realms alike, became the story of a planet alive with powerful, unpredictable forces. And as the silence lifts and the last wisp of ash drifts away, the world stands ready to remember the lesson of the gray days, that even when the sky itself seems to fall, life, ingenuity, and hope will rise again. A low, hollow roar begins deep beneath the surface, a tremor felt long before it is heard. In the days leading up to a super-eruption, the ground bulges and cracks as magma chambers swell with molten rock and gas. Seismic networks record thousands of small quakes, each pulse a heartbeat of the restless earth. Then, without warning, the ground shatters. A conical peak collapses into the void below, and the caldera vaults open like a wound, releasing unimaginable fury. Ash and gas explode skyward in a pillar that climbs through clouds and into the stratosphere. The initial blast punches a column of pulverized rock, glass shards, and sulfur dioxide more than 50 kilometers high. Within minutes, lightning streaks through the roiling plume, each flash igniting fresh pockets of ash and gas. Thunderous detonations follow, each reverberation a reminder that this is a global event, not a distant tremor. High above the weather layer, winds catch the volcanic plume and carry it outward in all directions. Fine ash particles smaller than a grain of sand mixes with sulfuric acid droplets formed as sulfur dioxide, converts to sulfur trioxide, and then reacts with water. These microscopic aerosols float in the stratosphere for months, even years, forming a veil that spans the globe. Beneath them, The troposphere remains clear of immediate fallout, but daylight already begins to lose its strength. By the next sunrise, the sun has transformed into a dim, ruddy orb. Its light passes through the aerosol layer, refracted and scattered, so that rays that once shone bright and white now arrive at the surface softened, diffused, and pushed toward the blue and red ends of the spectrum. Shadows blur and elongate, and colors fade toward shades of gray. Birds on early flights hesitate mid-wing beat, as if unsure where the day has gone. On the ground, ash begins to drift down. At first, it falls intermittently, a light dusting that coats leaves and rooftops. But as days pass, the ash shower grows steady. Like snow, it drifts into drifts, except each flake is a shard of volcanic glass that cuts lungs and corrodes steel. Farmers, without warning, awaken to fields buried under centimeters of ash. Road crews scramble to clear highways, but every sweep is undone by the next downpour of grit. Across the planet, temperature gauges register a sharp dip. Global average temperatures can fall by as much as several degrees Celsius within months, a shift equivalent to reversing decades of modern warming. Summers chill into frigid spring days. Frost returns to fields long past the last freeze. Monsoon rains delay or vanish, and the tropical belt shifts unpredictably, leaving billions to face drought or deluge. Crops fail first where seedlings lie unprotected in fields or gardens. Sunscreens of ash coalesce into a blanket that stifles photosynthesis, allies plant growth, and poisons leaves with acidic deposits. Rice paddies turn gray and still. Maize stalks wilt. Wheat springs up scorched. Food shortages spread in ripples from agricultural heartlands, triggering panic, price spikes, and forced migrations. Societies oriented around reliable harvests find themselves perched on the brink of famine. Wild ecosystems fare no better. Forests inhale ash into their canopies, needles clogged and branches snapped by the weight. Lakes darken as suspended particles cut off light, collapsing food chains from phytoplankton upward. Fish gasping at the surface become easy prey for birds, but few survive the combined onslaught of silt and acid. Grazing herds wander in search of clean pasture, trampling fragile ground as they move. Human history bears the scars of these events. The colossal Toba eruption some 74,000 years ago may have plunged Earth into a century-long volcanic winter, narrowing the window for our species' expansion. Genetic bottlenecks in early human populations hint at the struggle to survive under skies choked by ash. Only those who found refuge in equatorial zones, where aerosol layers thinned and seasons held on to heat, managed to endure. In our modern world, the stakes run even higher. Air travel screeches to a halt when ash clouds enter jet stream altitudes, silencing engines and grounding fleets. Satellites detect the aerosol veil, alerting climate models that forecast crop failures, energy shortfalls, and mass displacement. Electricity grids strain as demand for heating rises in the dimmed sunlight. Water supplies grow toxic with ash runoff, testing purification plants at breaking point. Yet volcanic aerosols also interact with greenhouse gases in complex ways. While sulfate clouds block solar radiation, they also provide surfaces for ozone-depleting reactions. Once the ash settles, lingering greenhouse warming can resume with added vigor, creating a roller coaster of extremes. Cold, then rapid rebound, then warming beyond previous norms. The atmosphere becomes an arena of competing forces, each vying to shape the planet's climate. Recovery from a super-eruption is measured in decades. Soils begin to heal as rains wash nutrients from ash into the ground, eventually fueling a flush of pioneer plants. Streams that once ran turbid with silt clear slowly as sediment settles. Aerosols settle out of the stratosphere first, then the troposphere, restoring sunlight in streaks. But landscapes scarred by pyroclastic flows or acid rain may take centuries to reclaim. Civilization, too, rebuilds, but not unchanged. Communities adapt with fortified greenhouses, underground farms, and resilient crop varieties bred for low light. Emergency food reserves and international aid become lifelines, easing the transition through the years of dimmed clocks and muted skies. And scientists, having forecast the eruption's progression, refine early warning systems, stratospheric sampling, and modeling to give future generations a head start against nature's fury. As the world breathes out the last of the ash, sunlight returns in muted glory paler, but no less welcome. Life stirs again beneath revived skies. Fields once centuries bare green up, and forests begin their slow reclamation. Yet the memory of that breath of fire lingers in the air chemistry, in ice core layers, in the DNA of resilient species that survived the coldest chapters, and ultimately in our shared knowledge of Earth's untamed power. Even when the sky clears, we carry the lesson of the supervolcano in every sunrise that breaks beyond the horizon, that beneath our feet, a molten heart pulses with the capacity to still the sun, and that our resilience resides in preparation, adaptation, and the enduring spark of life that persists through darkness and ash. By the end of the first week, fields that once rippled with wheat and barley lie under a uniform gray blanket. Each flake of volcanic ash, microscopic yet abrasive, settles on leaves and stems, forming a film that blocks out the sun's nourishing rays. Photosynthesis grinds to a halt. Chloroplasts, starved of light, begin to fail. Within days, tender seedlings wilt at their base as ash clogs stomata, the tiny pores through which plants breathe and transpire. Leaves droop and curl, unable to exchange gases or shed the weight of accumulating dust. Farmers awake to a world transformed. Where plows once turned dark, crumbly soil, now a fine silt coats every furrow. Tractors halt as air filters choke, engines ingesting ash-laden air that scours pistons and seals. Implements grow dull, metal edges eroded by abrasive ash particles. Irrigation canals designed for clear water become sluggish, carrying slurries of suspended ash that settle in ditches and block gates. Ground crews work around the clock, hosing down irrigation pumps and straightening bent pipes, but every task is undone by the next ashfall. As ash layers deepen millimeters, become centimeters, farm animals face a different peril. Grazing livestock stumble through pastures buried under dust. Hooves sink into ash-laden grass, each step kicking up choking clouds that scratch throats and coat lungs. Cattle noses, once soft and wet, crust over with gray deposits. Horses become lame when ash grit abrades hoof walls. Sheep and goats struggle to find palatable forage, their digestive systems clogged by silica-rich ash that scratches internal tissues. Farmers seize hay bales meant for winter feed, but even straw retains ash that mixes with fodder, reducing nutritional value and introducing toxins. The chemical assault of volcanic ash compounds the physical burden. Fresh ash often carries soluble fluorides leached from magma, which dissolve in rain or irrigation water. When deposited on vegetation, fluoride binds to leaf surfaces. Animals grazing on these leaves ingest toxic doses that accumulate over days. Fluorosis sets in. Teeth become pitted, bones brittle. Livestock grow weak, their gait unsteady. Within weeks, kidney and liver damage prove fatal. Veterinary teams, overwhelmed and undersupplied, can only advise segregation of clean feed sources, an impossible demand once every pasture bears the same taint. Ash in watercourses chokes rivers and streams. Fine ash particles saturate surface runoff, transforming crystalline clarity into opaque slurry. Inlets to wells and pumps clog with sediment. Aqueducts designed to carry fresh water become channels of gritty suspension that erode the edges and overwhelm filtration systems. Even municipal treatment plants strain to remove fine ash from drinking water. Conventional sand filters clog within hours. Backwash cycles stretch into days, and disinfecting agents react unpredictably with ash chemistry. Rural communities revert to rainwater harvesting, capturing the first flush before ashfall. But even that supply is short-lived as ash accumulates on rooftops and in catchment basins. Downstream, rivers swollen with ash-laden meltwater cut new channels, undercutting banks and depositing silt across floodplains. Fish populations crash as gills become clogged and insect larvae suffocate in silty shallows. Commercial fisheries halt. Rivers once teeming with salmon run dry of life beneath the murky veneer. Communities long dependent on riverine harvests confront hunger on multiple fronts, fields buried, pastures poisoned, rivers dead. The human toll escalates when staples fail. Early crops destined for summer harvest lie buried under ash. Root vegetables rot in fields blanketed by cold ash at frost's onset. Fruit trees lose blossoms and swell, but ash-laden petals collapse before pollinators can transfer pollen. Orchards fall silent as bees and insects vanish, unable to navigate the ash-choked air. Grocery store shelves, stocked for weeks, empty within days as supply lines falter under ashfall's broad sweep. Local markets become nodes of desperation. Prices for flour and canned goods skyrocket, and rationing begins. Malnutrition spreads swiftly in vulnerable populations: children, the elderly, the chronically ill. Hospitals overflow with patients suffering from respiratory ailments, aggravated by ash inhalation. Coughing fits that leave lungs raw, breathlessness that ravages the weak. Clinics distribute dust masks, cloth wraps that filter only larger particles, but these are scant among millions. Public health campaigns urge indoor sheltering, but crowded homes act as trap chambers, collecting ash on every surface. Cooking on open fires indoors fills rooms with ash-blurred embers, forcing residents outdoors into the choking gloom, or to choose meal fires that addict them to exposure. In rural districts, entire villages migrate toward urban centers, seeking relief in communal shelters. Highways clogged with ash-dusted vehicles funnel desperate families into refugee camps, hastily erected on stadium grounds and fairgrounds. There, soup kitchens operate round the clock, but the incoming grains, themselves contaminated during transport, require elaborate washing and screening. Even then, small stones and ash shards slip through, scratching the throats of the hungry who line up by the hundreds. Governments scramble to import food and supplies. Grain ships are routed to ice-strengthened ports, while overland convoys cut through ash-choked highways, escorted by military units to ensure security. International aid arrives, but the distribution network is overwhelmed. Local infrastructure, electric grids, communication towers, rail lines fail under the abrasive siege, leaving many regions isolated. Humanitarian corridors form, but only reach major cities. Outlying farming communities become invisible zones of acute famine. As the months pass, soil chemistry shifts. The raw ash layer interacts with rainfall, creating acidic runoff that leaches base cations calcium, magnesium, potassium from the topsoil. Nutrient-hungry crops attempt to root through the ash into soil that has gone sterile. Without lime or other ameliorants, soils acidify further, locking phosphorus into insoluble forms that plants cannot access. Soil testing laboratories operate by daylight hours only, compiling urgent reports on pH, nutrient deficits, and the presence of heavy metals, aluminum and fluoride, that pose long-term contamination risks. Agricultural extension agents, armed with data, recommend gypsum and phosphorus fertilizers, but supply chains remain disrupted by ash-choked roads. By the second year, a new pattern emerges. In regions where ash deposits have thinned, or where soils are naturally alkaline, certain hardy crops sprout again. Barley and rye tolerant of low light and acidic soils produce meager yields when planted in ash-tilled land. Buckwheat and lupins, able to fix nitrogen, help rebuild soil fertility. Yet widespread food shortages persist through slow yields and high seed-to-harvest ratios. International relief continues, but aid fatigue sets in as concurrent global crises draw resources elsewhere. Ecological succession attempts a reset. Pioneer species, willows and poplars colonize riverbanks where ash has washed away farmland. Pioneer grasses break the ash crust, their roots forging channels for water infiltration. Mycorrhizal fungi, introduced through seed packets and animal dung, spread subterranean webs that help bind nutrients in the soil. Birds carrying seeds in their droppings inadvertently plant patches of weeds and wildflowers that dance into existence, creating pockets of green in the gray landscape. Yet for human societies, the specter of mass famine lingers. Population loss reaches into the millions in the hardest-hit breadbasket regions. Economic collapse follows harvest failures. Grain prices double, then triple, as speculation grinds food markets to a halt. Governments impose strict rationing bread cards, milk vouchers, flour stamps, and deploy the military to enforce compliance. Civil unrest grows where urban refugees clash with local residents for dwindling stores. In that crucible, innovation flowers. Hydroponic greenhouses proliferate in urban centers where ashfall is lighter. LED-lit vertical farms produce leafy greens and microgreens, offering nutrient-dense supplements to the ration. Designers repurpose decommissioned shipping containers into insulated grow rooms, their walls scrubbed daily of ash that seeps through ventilation. Solar panels, once coated in ash, are fitted with automated cleaning wipers. Urban rooftops become vegetable gardens, soil patches restored with imported humus and lime. Still, the shadow of famine recedes only gradually. In some regions, centuries may pass before soils fully recover fertility and watercourses, clear of suspended ash and altered pH. Archaeologists millennia later find abandoned farmhouses half buried in ash layers, a testament to the silent suffocation that felled civilizations. Yet they also find terraces replanted, fields once drowned in gray, now blossoming green in renewed cycles, and communities that rebuilt resilient agronomic systems, crop diversification, seed banks, agroforestry belts that buffer against future ash events. Through it all, the lesson endures. When volcanoes unleash their ash clouds, the most vulnerable become the hungry. The silent suffocation of crops is not merely a moment of particulate slime. It is a cascade from leaves sealed shut, through poisoned soils, into choked waterways, and onto empty tables. It is the slow revolt of nature against human certainty, a reminder that our harvests depend on clear skies and living soils that require stewardship and preparation. Only by weaving early warning networks, rapid response cleanup systems, resilient crop strategies, and global solidarity can humanity hope to withstand the next gray dawn. A pall descends before sunset, a shroud drawn across the sky so suddenly that the late afternoon light sours within minutes. At first, the sun's disk blurs into a smudge of blood red, its rays diffused by volcanic ash high above. Shadows lose their definition, edges softening into indefinite gray. The horizon, once a clear boundary between earth and sky, becomes a smeared line of indistinct charcoal. In that gentle vanishing of color and form, the world seems to hold its breath, as if waiting for some unseen signal to plunge into deeper darkness. As dusk deepens unnaturally early, the stars fail to emerge. Normally, after the sun dips below the horizon, pinpricks of starlight glimmer almost at once: Polaris, Orion's belt, the Pleiades. But now an endless gray veil hangs overhead, blocking even the brightest constellations. The familiar Milky Way band, usually revealed in clear winter skies, remains hidden behind the ash-tainted firmament. No pinpoint of light appears to mark the path of travelers, no pinwheel of stars to guide nocturnal insects or migrating birds. All is muted flatness, an opaque lid that redefines night as an absence of both sun and stars. In the days that follow, the sky remains stubbornly dim. Pale diffuse light filters through ash layers, but direct sunlight never returns. Near noon, the world resembles permanent twilight, an hour of gloom stretched across every moment. People raise lamps and candles in mid-morning. In some regions, electric streetlights flicker on as early as 9 o'clock. Light meters record illuminance levels, equivalent to late evening in a city at polar night. Clouds glow dull and heavy, suspended in a haze of tiny glass shards, each flake too small to see individually, yet collectively thick enough to swallow daylight. Walkers in the open feel the difference in their bodies. Skin perceives a constant chill, as if the sun's warmth has been leased out to distant planets. Even on cloudless days, the ash-laden sky prevents the full spectrum of solar radiation from reaching the ground. Infrared warmth is scattered and reflected back to space. Ultraviolet light is almost entirely gone. Without UV to stimulate vitamin D production, humans sense a creeping fatigue as bones protest under gloom. Moods sag as serotonin levels fall without the sun's bright pulses. Animals react in turn. Birds that rely on dawn's first light to begin their songs fall silent. Robins and blackbirds pause in leaf-encrusted nests, unsure whether to feed their young or return to sleep. Owls, creatures of true night, falter in their rituals, slow to emerge and disoriented by the absence of their celestial cues. Nocturnal insects remain grounded, their compound eyes unaccustomed to such gray interiors. Bats wait beneath eaves, their sonar hunts delayed until faint starlight can penetrate the ash-choked air. Farmers struggle to read the weather. Without sun angles to mark midday, sundials are useless. Sheep in fields near ancient stone markers wander aimlessly, unsure where east or west lie. Vines cling to trellises, leaves limp as they struggle to photosynthesize. Crops destined for harvest show chlorosis, yellowing from lack of light and blocked stomata. Farmers mark days by ash thickness rather than sun position, measuring in centimeters of silt rather than hours of sunlight. Navigation turns treacherous. Ancient mariners once used the North Star, the Big Dipper, or the rising of Sirius to set course. Today, GPS satellites still orbit above, but their signals jitter when ash corrodes electronics. On land, compasses spin when ash-induced static pulses ripple through the air. Travelers learn to navigate by the pattern of drifted ash on signposts. Thicker drifts on northern faces, windward gaps on southern edges. Paths once clear become mazes of gray dunes, markers buried, landmarks erased. City dwellers evoke the hush of ash through shuttered curtains. Windows sealed against the grit become dark portals into a muted world. Inside, homes fill with the smell of damp stone and stale air. Families light lamps at dawn, gathering in living rooms that feel cavernous without daylight's regular cadence. Clocks continue to tick, but time seems unmoored. Breakfast blurs into lunch, extends into dinner. Daylight and night become abstract concepts rather than lived experiences. Electric grids strain under the increased demand for artificial lighting. Street lamps burn through power lines already weakened by ash's corrosive assault. Transformers overheat, their vents clogged, and towns fall into pockets of blackout. Hospitals switch to generators' noisy, smoky engines that fill the corridors with fumes as doctors and nurses measure patients by eye rather than reading instruments under proper light. Children do homework by lantern, their desks stacked with books to shield pages from turned ash. Schools adapt with makeshift curriculums. Lessons by lantern, sightless anatomy dissections under infrared lamps, geography taught by ash drift patterns. Teachers mark attendance by who can navigate the hallways blindfolded. Science classes become somber students, peer through ash-scratched lenses at wilted seedlings, tallying growth rates measured in millimeters per gray. History lessons take on a new poignancy. References to Tambora, Krakatoa, and Pinatubo become living nostalgia rather than distant footnotes. The sky's silence evokes a deeper stillness. The absence of airplanes overhead their contrails long gone as jets avoid ash-corroded engines, leaves airspace empty. The hush blankets everything. The drone of engines, the hum of traffic, the rumble of trains all fade into a void. Sound carries less when aerosol layers absorb high frequencies. Distant conversations lose clarity. In urban centers, people raise voices. Unnerved by the lack of ambient noise, lest silence become deafening. Astronomers despair. Observatories shutter domes when ash corrodes mirrors and lenses. Amateur stargazers lose access to telescopes. The heavens themselves retreat behind a fiberglass veil. Meteor showers vanish as trails of cosmic dust cannot ignite in a sky already saturated with terrestrial particles. Aurora displays, once dancing on polar horizons, dim into faint glimmers as solar-wind interactions fail to excite ionized gases shrouded by aerosol layers. Meteorological agencies repaint forecasts around the ash sheet. Satellite imagery shows a mottled veil spanning continents. Infrared sensors detect temperature inversions where the ash blanket traps cold air near the surface, a capping inversion that prevents storms from breaking through. Rain becomes acid-laced drizzles slithering across gray rooftops before evaporating. Without direct solar heating, convection stalls. Clouds form in shallow layers, never towering into thunderstorms. Lightning storms grow rare, thunderstorms silent, rainbows impossible. Psychologically, the effect is profound. Seasonal affective disorder becomes general affective disorder. People report dreams of color fields of green, skies of blue waking in tears at the memory of light. Artists paint on black canvases using ash as pigment. Musicians compose sonatas in low registers as if to match the muted world. Writers scribble by lamplight, recording in journals the precise hours of dimming and gloom. Pharmacies see a surge in antidepressants. Psychologists note a rise in agoraphobia, as venturing outdoors risks asphyxiation and despair. Yet human resilience adapts. Communities establish ash-clearing brigades, dressed in respirators and goggles, brushing sidewalks and rooftops to reopen paths. Sunlight lamps imported from unaffected regions line hospital wards, providing circadian regulation for patients. Urban parks cultivate light wells, areas cleared down to grass, ringed by reflectors to amplify the faint light. Schools install fiber optic, skylights rooted from rooftops that pierce the ash sheet by placing risers above the aerosol layer. Farmers build hoop houses blackened with tarpaulins to concentrate what little filtered light they can capture. Over time, a new cycle of twilight acclimatizes eyes and bodies. Pupils dilate wider. Melatonin responses reset to longer nights. Nocturnal creatures begin tentative forays into artificial dusk. Fungi glow faintly in forests, signaling to foragers where food may sprout beneath ash. Certain lichen species flourish on home walls, feeding on volcanic minerals and providing rare spots of verdant green. Human diets shift mushrooms, kelp, algae grown under artificial blue light become key sources of vitamins. Despite adaptation, the scars remain. Children born under the ash have retinas better tuned to low light, but cannot withstand direct conditions when the sky clears. Cultural memory codifies the ashen years. Festivals of light emerge. Lantern parades celebrate the return of the sun. Songs commemorate the gray decade. Astronomers, once deprived of stars, drive to remote mountaintops above the ash layer to reclaim views of the cosmos at altitudes above most aerosols. Each star rediscovered feels like a miracle. In the end, when winds finally shift and the sky begins to clear, the world watches the slow thinning of the ash veil like a curtain drawing back. Sunlight returns first as a dull amber, a promise of color to come. Then, in days and weeks, it brightens to golden white. Shadows regain their crispness. The horizon snaps back into sharp relief. And at last, under crisp night skies, the first stars emerge bright as hope after a long, colorless winter, and the Milky Way returns to its quiet, eternal glow. The sky without stars becomes, again, a sky full of them. By the time the ash plume has circled the globe, the Earth's thermostat has been thrown violently off its axis. In the stratosphere, billions of tons of sulfur dioxide, emitted in a single explosive eruption, have combined with water vapor to form a veil of sulfuric acid droplets. These fine aerosols scatter and reflect incoming sunlight, preventing much of the sun's warmth from ever reaching the surface below. As that solar dimmer switch is flipped toward darkness, temperatures begin to fall worldwide in a phenomenon known as a volcanic winter. Within weeks, satellite-based radiation monitors record a drop of several watts per square meter in net solar radiation at the surface. Surface air temperatures start to decline. In mid-latitudes, summer highs plunge toward springtime norms. By winter, cold intensifies, and frost returns to regions that once lay free of ice. Historical analogs give us a glimpse of this effect. After the 1991 Mount Pinatubo eruption, global average temperatures fell by roughly 0.5 degrees Celsius for up to 3 years. But a larger eruption can drive average surface cooling by 3 degrees Celsius or more, as ice core records of the 74,000-year-old Toba super-eruption suggest. The mechanism begins high in the atmosphere. Volcanoes emit sulfur dioxide, so into the stratosphere, above the weather layer where precipitation cannot wash particles out. There, the SO oxidizes into sulfuric acid, HE-Sol, condensing into fine droplets less than a micrometer across. These sulfate aerosols form a global aerosol layer that persists for 1 to 3 years, circling the hemisphere from west to east in a matter of weeks. Because they reside in the stable stratosphere, they have an E-folding residence time of roughly 12 to 18 months, with significant cooling effects lasting 2 to 3 years before gradual sedimentation removes them. As aerosols accumulate, they increase Earth's albedo, its reflectivity, by scattering incoming shortwave radiation back into space. At the same time, they absorb some long-wave, infrared radiation emitted from the surface, warming the lower stratosphere but cooling the troposphere below. The net effect is a reduction in surface heating that plunges the planet into cooler conditions. High-latitude summers become too cool to fully melt winter ice. Sea ice expands, reflecting yet more sunlight and amplifying the cooling, a classic ice albedo feedback. The first signs of this planetary chill appear in regional climate patterns. Monsoonal systems weaken as land-sea temperature contrasts shrink. In South Asia, summer rains falter, river runoff declines. Agriculture stalls. In East Africa, short rainy seasons fail. Crops wither. Pastoral herders find no pasture for their livestock. North American growing seasons contract by weeks, sometimes months, threatening staple crops like maize, wheat, and soy. In Europe, a year without summer descends as cold and famine spread across the countryside, echoing the post-Tambora famines of 1816. Global average temperature curves flatten, then dip. Instrumental records after Pinatubo show a 0.4 degrees Celsius drop in global mean surface temperature within 6 to 12 months of the eruption, peaking at around 0.7 degrees Celsius reduction 2 years later. A Toba-scale eruption 50-10 kilograms of SO could drive 3-5 degrees Celsius cooling for several years, rivaling Pleistocene stadial events. In equatorial regions, the effect is muted, but still felt. Mountain glaciers advance, tree line contracts, and coral reefs bleach under diminished irradiance and cooler water. Seasonal cycles are disrupted. Winters grow longer. Frost occurs earlier in fall and later in spring. Permafrost layers that once thawed each summer remain frozen year-round, locking in methane, but also halting plant decomposition. Boreal forests suffer increased dieback, where cold snaps damage trees unaccustomed to extreme chill. Spring emerging insects pollinators essential to many crops fail to synchronize with bloom periods. causing cascading ecological mismatches. Atmospheric circulation patterns shift under the stratospheric heating caused by aerosol absorption. The polar vortex strengthens, pushing cold air toward mid-latitudes. Jet streams intensify, becoming more zonal and less meandering, locking weather patterns into prolonged cold spells or droughts. Tropical storm tracks change as well. Hurricane seasons shorten, where surface ocean temperatures fall below thresholds needed for cyclone development. Marine ecosystems also feel the pinch. Cooler surface waters reduce stratification, altering nutrient upwelling. Phytoplankton blooms change timing and species composition, affecting marine food webs from copepods to fish to seabirds. In the North Pacific, salmon returns falter. In the Southern Ocean, krill densities drop. Fisheries collapse in regions dependent on stable ocean temperatures, compounding food security crises on land. Agriculture endures the gravest threat. Crop yields collapse in successive seasons under dimmed sunlight and shorter growing periods. Historical records from Tombora's year without a summer show widespread frost in every month and harvest losses across New England and northern Europe. Grain prices spiked fivefold in some regions. Famine and social unrest followed. A larger eruption could dwarf these effects, triggering global crop failures, mass malnutrition, and cascading economic collapse. Human societies respond as climates grow hostile. Food crises spur migrations from rural to urban areas, overwhelming cities that must feed swelled populations under worst-case supply disruptions. Governments enact emergency rationing and import grain reserves, but global shipping routes choke on ash-damaged ports and clogged waterways. Energy demand soars for heating. Power grids falter under the stress of increased usage and ash interference in transmission lines and power plant intakes. Health impacts multiply. The combination of colder temperatures and malnutrition weakens immune systems. Respiratory diseases spike as people burn biomass indoors to stay warm, inhaling ash-covered smoke. Ultraviolet radiation declines, raising risks of vitamin D deficiency and related bone disorders. Mental health suffers under extended gloom and food insecurity, with rates of depression, anxiety, and suicide increasing in affected regions. Yet volcanic winter is not purely devastation. It also offers windows for innovation and adaptation. Historical famine relief efforts, grain reserves, food redistribution systems, seed banks might inform modern responses. Greenhouse agriculture shields crops from dimmed sunlight, using supplemental lighting powered by stored energy or geothermal heat. Selective breeding of cold-tolerant, low-light crop varieties becomes a priority. Infrastructure is hardened. Ash-resistant filters for power plants, railways, and urban HVAC systems. Modular housing designs that trap residual heat. Public health campaigns to minimize indoor pollutant exposures. In scientific terms, volcanic winter is among the most extreme but rapid climate perturbations Earth can experience. Unlike the gradual warming of anthropogenic greenhouse gases, volcanic aerosol forcing acts on timescales of months, initiating feedbacks that can freeze systems in prolonged cold. The Earth's energy budget swings abruptly negative, and only over years, often decades, do the aerosols clear. Ice retreat, and systems rebound to their pre-eruption states. Paleoclimate records attest to multiple volcanic winters across geologic time. The Toba event, 74 Shia, the Samalis eruption in 1257 CE, and the mid-6th century extreme weather events, likely driven by Krakatoa or Ilopango. In each case, major societal shifts, migrations, population declines, cultural transformations correlate with the abrupt dips in temperature documented in tree rings, ice cores, and sediment layers. Looking forward, monitoring volcanic gas emissions and aerosol loading in the stratosphere provides crucial early warning of impending cooling. Satellite sensors like NASA's OMI and Calypso track sow plumes and aerosol optical depth, feeding into climate models that forecast surface impacts. In tandem, ground-based observatories measure sky radiative fluxes, validate model predictions, and guide policy decisions on food security and energy resilience. When a super-eruption eventually stirs the Earth's depths again, humanity's preparedness will hinge on our ability to anticipate and mitigate the great temperature drop. By understanding the physics of sulfate, aerosol scattering, the geography of sunlight deficit, and the vulnerabilities of our globalized systems, we can build buffers, diversified crop portfolios, decentralized energy networks, robust public health protocols, and international collaboration on resource sharing. The breath of fire that plunges the planet into volcanic winter is a reminder of Earth's living dynamism, a force as primal as wind and sea, as relentless as solar cycles and tectonic upheavals. Yet within that force lies an invitation to learn, to plan, and to engineer resilience in the face of sudden cold. For in the long arc of geologic time, hardship has always paved the way to innovation, and the frozen trials of volcanic winter may yet forge the ingenuity that ensures life as persistence under an ever-changing sky. The moment ash begins to drift into the ocean, sunlight on the waves turns from sparkling blue to a muted gray. Fine glassy particles settle into the water column, each grain suspended before slowly descending toward the seafloor. This ash layer acts like a lid over the sea, scattering light and casting a diffuse gloom through the upper meters of water. Beneath the surface, the world dims, and everything that depends on the sun's energy feels the pinch. Even the gentle lapping of waves becomes hushed, as if the sea itself recognizes the weight of a new burden. Within hours, ash particles infiltrate the ocean's skin layer, where much of the marine food web begins. Phytoplankton, microscopic plants that fuel entire ecosystems, rely on sunlight to photosynthesize. When light levels drop, their chloroplasts falter and growth rates plummet. In clear water, a bloom can double its biomass in days. Under an ash-shrouded sky, those numbers stall or reverse. Satellite imagery from past eruptions shows chlorophyll concentrations collapsing to a fraction of normal as oceans enter a temporary night. Yet ash does more than block light. Its chemistry can fertilize surface waters, delivering iron and other micronutrients that plankton crave. Under some conditions, ash falls have triggered blooms of phytoplankton, visible from space as emerald swirls against the dark. But these blooms often favor a few hardy species, leading to monotypic patches that lack the diversity needed by fish larvae and zooplankton. In this upheaval, food webs decouple predators, arrive to find only thin soups of organisms where rich pastures once thrived. Coral reefs face a dire fate when ash settles on their delicate structures. Reefs exist at the threshold of light and nutrition. Even a brief ash burial can choke polyps beneath a coating of fine dust. Without sunlight, their symbiotic algae, zooxanthellae, starve and expel themselves, leaving bleached skeletons alive but weakened. Repeated ash falls prevent recovery, and without new algal recruits, whole reef sections can die. In the immediate aftermath of the 2022 Hunga Tonga eruption, researchers found ash layers over reef flats, almost a meter thick, suffocating corals that had thrived for centuries. Where reefs die back, the balance of life shifts abruptly. Species that once depended on nooks and crannies of living coral must flee or starve. Parrotfish and surgeonfish, grazers that keep algae in check, vanish first. Algae and cyanobacteria take over bare skeletons, forming black reefs that resist the return of coral polyps. Mobile invertebrates, shrimp, lobsters, sea urchins disappear as their hiding places and food sources dissolve under ash. Fish populations collapse, and the vibrant colors of reef life give way to muted browns and grays. In deeper waters, ash drapes across the abyssal plains. Bathyal and abyssal ecosystems often rely on a steady rain of detritus from above. When ash contaminates this organic snowfall, Microbial decomposers face a mixed diet of rock and food. Some bacteria can metabolize volcanic glass, but the process is slow and energetically costly. In areas near submarine vents, ash layers can smother active vent communities, burying tube worms, clams, and specialized crustaceans beneath a blanket of sediment. These communities, isolated and slow-growing, may take decades or longer to recover. Filter feeders in coastal zones bear the immediate brunt of ash-laden waters. Mussels, oysters, and barnacles strain plankton through their gills, only to clog their feeding structures with abrasive ash. Their clearance rates plummet, growth slows, and reproduction fails. In extreme cases, massive die-offs of bivalves have been recorded within weeks of major ashfalls. Estuaries and mangrove forest, nurseries for countless fish, turn into muddy graveyards where juvenile shrimp and crabs suffocate in the gritty gloom. Pelagic species feel the shock farther offshore. Zooplankton, the tiny drifters that graze on phytoplankton, face both starvation and abrasive injury. Their delicate exoskeletons, built for filtering food, are ill-equipped to handle shards of volcanic glass. As zooplankton densities decline, fish larvae lose their primary food source, leading to cascading failures of recruitment. Tuna, mackerel, and other commercially important species see dramatic dips in juvenile survival, foreshadowing lean years for fisheries. Seabirds and marine mammals are the next to suffer. Puffins, petrels, and albatrosses find their prey scattered or vanished, forcing longer flights and riskier dives. Oil-like slicks of ash-laden water cling to feathers, destroying waterproofing and insulating layers. Birds drown, hypothermia sets in, and nesting success plummets. Seals and sea lions find ice floes coated in ash, their breathing holes clogged, and haul-out spots covered in dust that stings eyes and lungs. Krill, the tiny crustaceans that sustain whales, penguins, and seals, can vanish almost overnight. In polar regions, spring blooms of diatoms feed swarms of krill. Ash shading delays or suppresses these blooms, leading to krill gaps that leave whales stranded with empty bellies. Baleen whales arrive at feeding grounds to find water colored gray instead of green, and must search longer, travel farther, or eke out a living on whatever meager patches of life remain. In Antarctica, simulations suggest ash layers of just a few millimeters could reduce krill populations by more than half. The disappearance of these keystone species rewires entire food webs. Jellyfish, opportunistic and resilient, often thrive when competitors falter. Blooms of moon jellies and cone jellies cloud the water column, preying on fish eggs and further suppressing recruitment. Their proliferation feeds sea turtles and larger jellies, but offers little nutritional value compared to fish. Coastal ecosystems transform into gray, gelatinous deserts, where once active marine biodiversity falls silent. Coral atolls in the tropics become graveyards of broken skeletons. Without fish to graze down algae, macroalgae carpet reef flats. Soft corals and sponges take over, hosting new assemblages of invertebrates that can tolerate ash-rich water. These novel ecosystems may persist for decades, but the original reef builders struggle to reclaim territory. Coral restoration efforts, once centralized on outplanting nursery-grown fragments, must contend with ongoing ashfall and acidic runoff that hinder polyp attachment and growth. Beyond coastal zones, open ocean currents distribute ash and aerosols into gyres and convergence zones. Microplastics already concentrated in these regions mix with volcanic dust, creating complex assemblages that filter feeders ingest indiscriminately. Studies show plastic ash aggregates form denser particles that sink rapidly, dragging microplastics and attached toxins to the seafloor. Benthic filter feeders like sponges and sea cucumbers accumulate these composite particles, introducing new pathways for plastic to enter deep-sea food webs. In polar seas, seasonal melt cycles interact with ash deposits. When sea ice forms, it traps ash within its crystalline structure, carrying it across the ocean before releasing it in meltwater blooms. Freshwater lenses on the surface create stratification that traps phytoplankton in darker layers, cutting them off from mixed nutrients below. Melt ponds turn coffee-colored with ash, altering methane emissions and microbial community composition. These changes contribute to feedback loops that affect sea ice thickness and timing of freeze-up, impacting polar ecology season after season. Volcanic ash also influences the carbonate chemistry of seawater. Ash particles can release silicate and aluminum ions, which in turn bind with carbonate ions, subtly shifting the balance of dissolved inorganic carbon. In regions where upwelling already lowers pH, this additional acid challenge exacerbates coral stress and shellfish dissolution. Laboratory experiments reveal that oyster larvae exposed to ash-amended seawater show stunted shell growth and increased mortality, a warning for natural populations that are already vulnerable to ocean acidification. The human dimension of these marine upheavals is stark. Coastal communities dependent on fisheries face unemployment, food insecurity, and economic collapse. In the Pacific Islands, reef-based tourism halts as beaches and coral gardens turn gray and lifeless. Aquaculture operations must treat intake water with finer microfiltration technology to protect shellfish beds, driving up costs and reducing yields. Governments scramble to implement disaster relief measures, but international aid networks strain under simultaneous land and sea crisis. Scientific monitoring becomes a race against time. Oceanographic vessels deploy CTD rosettes to measure ash concentrations, turbidity, and water chemistry at depth. Autonomous gliders map the extent of ash-laden lenses, while satellites track changes in ocean color. Genetic assays reveal shifts in plankton community composition, alerting researchers to emerging algal blooms or collapses. Collaborative networks of marine biologists, chemists, and fisheries managers analyze data in real time, seeking windows of opportunity for intervention. Restoration strategies emerge from this crucible. Floating booms designed to intercept surface ash offer partial relief for nearshore reefs. Underwater suction devices clear ash from coral branches, mimicking sediment removal efforts after hurricanes. Selective breeding of coral genotypes with greater tolerance to particulate stress accelerates recovery in nursery settings. Hatcheries rear planktonic larvae of bivalves and fish, releasing them into cleaner pockets of water to repopulate depleted stocks. These efforts require unprecedented levels of coordination across nations. Over the years, storms and currents gradually flush ash from coastal shelves. Rain and river runoff carry sediment into deltas, where it is trapped behind mangrove roots. These wetlands, once threatened by deforestation, become vital buffers, filtering ash out of coastal waters before it reaches fragile reefs. Mangrove restoration projects, using species adapted to high turbidity, prove lifesavers for coral ecosystems down-current. Deep reefs, previously unknown refugia, offer surprise havens for recodify. At depths beyond the reach of the densest ash layers, mesophytic corals and sponges survive in twilight conditions. Genetic connectivity between these deep assemblages and shallow reefs provides larvae that can reseed devastated areas once conditions permit. Conservationists designate these mesophytic zones as lifeboat reefs, protecting them from trawling and pollution to safeguard future recovery. By the time a decade passes, the worst of the ash cloud has dissolved or settled into ancient sedimentary layers. Sunlight again warms the upper ocean, fueling renewed phytoplankton blooms and the return of zooplankton grazers. Coral recruits settle on cleaned skeletons, and fish schools patrol regrowing reefs. Seabird colonies expand again, and whales follow krill pulses back to polar feeding grounds. Marine ecosystems gradually rebound, their scars still visible in geomorphic ash terraces and archaeological midden layers, but life, as always, proves persistent. In these cycles of suffocation and revival, The ocean's story is one of both vulnerability and resilience. Volcanic ash can choke and poison, but it also delivers vital nutrients and scours away disease vectors. The pendulum swings between collapse and renewal, shaped by currents, biology, and human stewardship. When skies clear and the last ash drifts away, the sea carries memory in its chemistry. Genetics and sediment record witness to a moment when Earth's fiery breath reached below the waves and tested the boundaries of life itself. Gray light filtered through the ash-shrouded sky as the first flakes settled on the city's high-rise rooftops, carpeting gravel, vents, and satellite dishes alike. At dawn, the world seemed unchanged, empty streets, silent buildings, but each passing hour brought new weight. Each silent inch of ash, a subtle shift in the balance between structure and collapse. Pigeons that dared to land on window sills beat their wings into the soft drifts, sending tiny avalanches of fine gray grit down facades. In the dim glow of early morning, the city looked dusted with frost, but there was no warmth in the pattern, only the promise of ruin. By mid-morning, the first gutters began to buckle. Engineers who once advised on stormwater flow now watched with mounting alarm as ash wet with acidic condensates from volcanic gases stuck to every surface. Inch-thick blankets of ash weighed down sheet metal roofs, bowed eaves, and sagged into rain channels. Builders knew the breaking point. Around 10 centimeters of wet ash could crush a poorly supported roof. Tonight's snowfall would bring that critical mass. With every centimeter, the possibility of collapse accelerated, and the city braced for the inevitable. On tenement blocks where buildings leaned close together, ash piled between narrow courtyards until fences vanished beneath gray hills. Residents on lower floors swept and shoveled in a futile dance, only to see new layers cover their work within the hour. The ash was relentless, one continuous drift, transforming alleys into dunes and burying porches under the weight of invisible wind currents. People bundled up in scarves and goggles emerged to clear fire hydrants in doorways, carving narrow tunnels to the street. But there was no keeping pace with the unending downpour of grit. Cars parked curbside were soon unrecognizable. Windshields cracked under the weight of accumulating ash. Wipers scratched delicate glass, and doors jammed in their frames. Engine air filters clogged, and drivers abandoned vehicles wherever they stalled. Rush hour traffic dissolved into a vast graveyard of half-buried sedans and buses coated in fine gray dust. Parking garages, once open to the sky, filled with ash that slid like sand, piling in drifts 5 feet deep in corners where no one thought to look. In the financial district, skyscrapers stood like empty shells, their reflective windows dulled to matte gray. Maintenance crews donned respirators and rappelled down facades, chipping away blast furnace hot ash from ledges above. They worked in silence, communicating by gesture, each movement precise, lest a dislodged chunk send them tumbling into the miasma below. From street level, passers-by looked up at their silhouettes, tiny figures against a yawning abyss of cloud-choked air. Municipal services scrambled. Snowplows and street sweepers, designed for winter storms, found themselves feeding on an endless buffet of volcanic ash. Their brushes wore away in hours. Their filters clogged so quickly that crews spent more time cleaning machines than clearing roads. One plow sank into a drift and never emerged. Fire trucks, emergency ambulances, and delivery vans lurched to a stop as intake grills filled. The city's arteries spasmed and closed, and traffic lights blinked into darkness as power transformers choked on dust. Hospitals became islands of light surrounded by gray silence. Generators hummed through nights without rest. Doctors and nurses moved down corridors in hazmat suits, monitoring patients who coughed and gasped under the same ash that crushed rooftops above. Each breath tasted of metal and fear. Intensive care units overflowed with those suffering from inhalation trauma lungs, scarred by abrasive glass fibers. Even inside sealed rooms, Bandaged vents whispered the constant need for fresh filters. Businesses shuddered as employees stayed home, fearful or incapable of braving the toxic haze. Cafes closed shutters, their coffee machines cold. Supermarkets locked doors as aisles grew murky under the dusty gloom. People rationed canned goods salvaged from basements, cooking by lantern light and wood stove hearth, avoiding stoves whose chimneys choked on ash. A marketplace once filled with chatter and transaction became a silent hall of locked gates and drifting ash, each package of rice a treasure guarded by wary hands. Schools canceled classes indefinitely. Playgrounds turned to ghost fields of slides and swings, half buried in ash drifts. Children watched from windows, faces pressed against grimy panes, dreaming of sunlight and grass. Teachers held lessons by radio broadcast, their voices crackling through frequencies coated in static from ash-soaked antennas. Assignments arrived on paper taped to classroom doors, mailboxes blocked by drifts of ash, too deep to dig through without risking collapse. In affluent suburbs, mansions with pitched roofs fared better than low-slung apartment blocks, but they still bore the weight of disaster. Tree branches snapped under the weight of ash, splintering roofs below. Lawns vanished beneath gray dunes. Swimming pools filled with silk-gray slurry that killed every algae bloom and fish. Gardeners fought a losing battle, pruning brittle hedges and clearing flower beds beneath the suffocating shroud. At City Hall, engineers huddled with meteorologists around ashfall charts. They predicted another 3 days of heavy fallout. They ran scenarios. If ash depth reached 20 centimeters, every flat-roofed building in the central district faced imminent collapse. They drew evacuation zones, mapped out safe shelters, and sent workers to reinforce critical structures, schools, hospitals, police stations. Volunteers wrapped tarps over vulnerable roofs, piling sandbags around edges to prevent ash from drifting in measures that bought hours, perhaps days, but could not reverse the siege. As evening fell, a piercing creak echoed across the silent streets. On a block of row houses, a roof gave way, unleashing a cloud of ash that billowed down an alley. The collapse was muffled, a dull release of energy that was both final and complete. Windows shattered under the load, walls buckled inward. Neighbors rushed with shovels, kicking aside drifting ash to rescue those trapped beneath. They emerged with ashen faces and wide-eyed relief. Moments like this braided fear and hope, the knowledge that each collapse could be the last. Emergency sirens sounded, faint and distant, their tones warped by the dense sky. Rescue teams navigated streets turned into shifting dunes, guided by GPS units that sputtered under ash interference. They searched for survivors, their boots sinking into the soft gray carpet, marking trails of disruption where hope flickered. In one corner, a child's toy lay half buried. In another, an elderly man clung to an oxygen tank, his canister's gauge teetering toward empty. Rescuers worked by the pale glow of floodlights mounted on trucks, dusting ash from each face to reveal the human toll. Above it all, the sky remained a locked vault of ash and aerosol, unchanging in hue. Meteorologists noted the stratospheric cloud's persistence, warning that winds would not shift for weeks. The sun, when glimpsed through breaks in the ash band, appeared as a blood-red coin, its heat deflected back by the reflective cloud. Temperatures dropped. Cold seeped through walls and windows. The city, once known for its temperate climate, now felt like a hollow beneath a dome of ice and soot. Water mains froze where they ran shallow. Hydrants cracked under the cold, leaking jets of water that turned to rime ice. Firefighters discovered that water pumped from hydrants carried ash so fine it choked hoses and clogged nozzles. They learned to use sandy grit to scour ash from hydrant caps before opening valves. In some suburbs, residents built makeshift ice houses to store perishables, a survival strategy drawn from memories of polar expeditions, now playing out in their own backyards. Mass transit lines lay silent. Subway entrances were closed off as ash filtered down stairwells, coating platforms and tracks. Trains, shuttered in underground garages, were buried under drifts that crept through ventilation grates. Elevated rail lines sagged under ash that collected in the trackbed. Signals failed when dust interfered with electrical contacts. The network that once wove life through the city ground to a halt, leaving commuters stranded in neighborhoods that became islands of gray. Airports, once buzzing with arrivals and departures, were deserted. Runways were unreadable under a uniform skin of ash. Air traffic controllers watched radars that traced nothing but the ash cloud itself, a swirling mass circumnavigating the globe. Planes that dared attempt takeoff risked engine failure as turbines ingested fine glass fragments. Pilots reported cockpit lights flickering as ash overloaded cabin filters. Hangars filled with grounded jets became gray catacombs, where each aircraft waited for the day it could once again feel the thrust of clean air. The collapse of industry followed. Factories that depended on outdoor intake vents shut down. Warehouses lost roofs. Cargo inside was ruined by ash that seeped through every crack. Refineries found their cooling towers choked. Distillation columns coated in dust that altered chemical reactions. Electric utilities ran emergency blackouts to protect transformers, leaving neighborhoods dark as they fought to protect the grid. Hospitals and emergency centers received priority, but many buildings went days without power. Communication networks strained to carry messages. Cell towers coated in ash experienced antenna detuning. Signals thinned as dust clung to every surface. Landlines offered a brittle lifeline, but underground cabling was damaged where ash-laden water seeped into conduits. Radio stations broadcast emergency frequencies. Amateur ham operators became vital by relaying messages to areas cut off from conventional networks. In a world of collapsed cities, every voice, every transmission became precious. With days stretching into weeks, the ash siege turned familiar. Residents developed routines. Ash watches at dawn, when crews measured new depths, street shoveling between meals, breaks to warm hands over small fires in metal drums. Children listened to bedtime stories by lantern, drifting to sleep under wool blankets, soot-caked pillows propped against ash-streaked walls. In dreams, they ran through green fields and blue skies, worlds rediscovered in sleep. As the city slowly transformed into a gray tomb, its inhabitants adapted in small ways. Roof watchers stood on balconies, tapping surfaces with poles to test for dangerous sag. Community brigades formed to clear narrow escape corridors between buildings. Rooftop gardens morphed into emergency lookouts, their planters packed with sandbags to weigh down tarps. Old irrigation channels diverted ash-laden runoff from vulnerable doorways. Every collapse taught a grim lesson. Never underestimate the ash's power. When one building came down, a chain reaction followed as neighbors saw walls, shared by party walls, buckle under the new load. City planners later calculated that a dozen blocks of row houses had collapsed, not from seismic shocks, but from the unseen gravity of volcanic dust. Entire neighborhoods became rubble fields, their streets filled with jagged wood and concrete shards, each fragment coated in ash like antiquarian artifacts awaiting archaeologists. In the end, the city was half buried, its skyline reduced to shards and chimneys. Where towers had once gleamed, only skeletal steel frames remained. Streets were unrecognizable, drifts of ash carving canals between collapsed facades. Silence reigned, broken only by the creak of strained supports and the distant murmur of clearing crews that worked from dawn until dusk. No birds sang, no cars honked. Even the wind moved sluggishly, weighed down by the lethal dust. Yet in this void, life endured. The weak beams of survivors' lanterns flickered in boarded windows. Food ration lines snaked through the gray forges of desperation. Children huddled in shelters, sharing stories to keep spirits bright. Rescue teams cleared corridors inch by inch, greeting each rescued family with shouts of relief. Engineers examined the wreckage for salvageable steel and concrete, planning reconstruction even as piles of ash towered above them. And so, amid the ruin of collapsed cities, a new city began to rise in the hearts of its people, and in the slow hope of re-clearing one street at a time. Beneath the layer of ash and collapse lay foundations waiting to be reused, memories waiting to be rekindled, and a stubborn belief that even under a vault of gray, life would reclaim the rubble and rebuild. Gray ash drifts through the air like shards of sky, each particle a tiny fragment of volcanic glass, capable of cutting through the soft passageways of the human respiratory system. From the moment the first plume settles, airways clog and eyes sting with microscopic grit. Inhaling draws these particles deep into the lungs, bypassing throat and bronchi, until they lodge in the alveoli, those whisper-thin sacs of tissue where oxygen crosses into blood. Each breath becomes a negotiation with danger, as glass-like ash abrades sensitive membranes, triggers inflammation, and blocks the very pores meant for life's essential exchange. Within hours of an ashfall, hospitals fill with patients struggling for breath. Coughs erupt in spasms, rattling against lungs coated in fine dust. Asthmatics gasp for relief, their airways constricted by bronchospasm and coated in abrasive soot. Elderly individuals, whose lung capacity has dwindled with age, feel every inhalation as if drawing smoke from a fire. Children, whose bronchial tubes remain narrow, face wheezing attacks that strain tiny chests. Even healthy adults find exertion punishing. Every step, every word, demands more effort as oxygen-starved tissues cry out for the simple act of breathing. The mechanics of lung injury under ashfall resemble occupational silicosis, yet move faster, more acutely. Silica particles lodge in the distal air spaces, provoking a cascade of cellular damage. Alveolar macrophages, immune cells tasked with clearing invaders, engulf ash fragments, only to be poisoned by sharp edges and toxic surface coatings. These dying defenders release chemical signals that draw more inflammatory cells, swelling the lung tissue and thickening the alveolar walls. Gas exchange slows as membranes stiffen and blood oxygen levels drop. In severe cases, acute respiratory distress syndrome, RD, follows, requiring ventilator support to keep patients alive. Across communities, the numbers climb. A single large eruption can spike hospital admissions by hundreds of %. Rural clinics, ill-equipped for respiratory crisis, send fevered patients on risky journeys to city hospitals, their roads clogged by ash-choked traffic. In urban centers, emergency rooms overflow with visitors clutching inhalers and oxygen masks. Chronic problems swell hospital rosters. Bronchitis, pneumonia, and secondary infections exploit weakened lungs. Physicians rush to diagnose silicosis-like presentations in patients who never worked in mines but live under a ceiling of volcanic dust. Masks become lifelines, but they are in short supply. Surgical masks, designed to block droplets, do little against submicron ash particles. N95 respirators seal the face, filtering out a majority of airborne grit, but require proper fit and frequent replacement. Volunteer seamstresses stitch cotton layers into makeshift masks, offering some protection, but nowhere near the barrier of certified filtration. Children refuse to wear ill-fitted coverings, and the elderly struggle to breathe through dense fabrics. Each mask is a compromise, reducing exposure but never eliminating the silent suffocation of unrelenting ash. Even indoors, safety remains elusive. Ash infiltrates homes through ventilation shafts, cracks around window frames, and under door sweeps. Ceiling fans recirculate dust. Air conditioners sputter as filters clog with volcanic glass, forcing residents to choose between stale, choking air or failure of cooling systems. Families press damp towels against thresholds, erect plastic barriers in doorways, and tape windows shut. With every sweep of the broom, new layers settle. The home becomes a gauntlet. Only sealed rooms, if such sanctuaries exist, offer respite, and then only for so long before ash breaches their defenses. Water supplies fare no better. As ash-laden rain falls, catchment basins fill with abrasive sediment. Reservoirs turn murky brown, suspended particles clog intake screens, and treatment plants struggle to remove grit before chlorination. Ashy runoff acidifies rivers and canals, releasing fluorides and heavy metals that dissolve into water. Drinking from the tap becomes a calculated risk. Raw water must be boiled, filtered through layers of cloth, even treated with chemical coagulants to settle out the finest ash. Yet every measure sifts away only part of the hazard, and communities reliant on well water find their pumps choked, their wells poisoned by ash infiltrating groundwater. In villages downstream, kerosene lamps and portable stoves whistle through nights of water scarcity. Mothers boil what little they can collect, teaching children to sip cautiously, to avoid coughing on gritty gulps. Clinics distribute water purification tablets, but coverage is spotty. Diarrheal diseases surge when contaminated ash-heavy water meets compromised immune systems. Gastroenteritis sweeps through shelters, where families huddle for warmth, each bout of illness compounding malnutrition from disrupted food supplies. Human resilience frays under the twin weight of choking air and poisoned water. The toxic chemistry of volcanic ash compounds every crisis. Sulfur dioxide and hydrogen fluoride stick to glass shards, creating acid-coated spears that burn skin and corrode fabric. Inhalation delivers fluoride directly to lung tissues and bloodstream, risking skeletal fluorosis and dental mottling. Aluminum and heavy metals wash into waters, accumulating in fish and shellfish, turning riverbanks into no-go zones for fishing communities. Unchecked, these contaminants can cause long-term organ damage. Kidneys, liver, and nervous system fall under lethal siege once the ash burden overwhelms natural detoxification. Healthcare workers shoulder heroic burdens. In hospitals, staff don protective gear, goggles, gowns, respirators, becoming faceless figures in the gray haze. Corridors echo with the wheeze of ventilators and the beeps of monitors tracking oxygen saturation. Nurses suction airways, clearing ash from tracheostomies as they prepare sedated patients for intubation. Mobile clinics venture into worst-hit neighborhoods, armed with nebulizers and portable oxygen. They conduct door-to-door visits, screening the elderly and infirm, triaging those in desperate need. Every visit becomes a gamble with their own health, as ash infiltrates every protective layer. Schools double as shelters, their classrooms transformed into triage centers. Desks are replaced by cots. Chalkboards record patient numbers and water ration schedules. Teachers, exhausted from shifting roles, hand out masks and instruct on breathing exercises, pursed lip breathing, diaphragmatic breathing, to ease panic and improve oxygen intake. They read sterile instructions. Clean water only, mask use mandatory, seek help if breathing grows labored. Yet the halls, once brimming with youthful energy, hush to anxious whispers as students learn to ration every inhalation. Psychological strain deepens the physical distress. Agoraphobia grips families who dare not step outside. Panic attacks ripple through crowds struggling for the next breath. Nightmares plague the young dreams of collapsing ceilings, stifling darkness, lungs filled with sand. Therapists, in short supply, offer group sessions by candlelight, mindfulness to calm the hyperventilating, guided imagery to imagine clean air and flowing rivers. Each session is an act of defiance against the gray pall overhead, a reminder of life's capacity to find stillness even when breath itself feels under siege. Long-term health impacts trail behind the immediate crisis. Chronic obstructive pulmonary disease, COPD, diagnoses rise as acute exposures become chronic insults. Survivors of RZ may carry scars, fibrotic plaques, stiffened lung tissue that limit capacity for years. Pediatric pulmonologists monitor children for developmental delays in lung function. Adult survivors find ordinary exertion climbing stairs, lifting groceries, a battle against broken reserves of breath. Even those who escape serious injury live with a new wariness. Air quality apps become routine checks. Personal monitors beep at particulate spikes. Every cough triggers an alarm. Amid the struggle, public health networks mobilize. The International Volcanic Health Hazard Network issues guidelines. Stay indoors. Use high-efficiency particulate air, HEPA filters. Avoid strenuous activity. Governments distribute masks N95 to frontline workers, surgical masks to the general public, and install portable air cleaning devices in schools and clinics. Mobile water treatment units deployed to rural areas, engineered for ash-laden inflow, using flocculation tanks and rapid sand filters to remove sediment. Yet logistics falter when roads collapse under ash drifts and vehicles stall with overloaded filters. Humanitarian corridors form. Military convoys deliver bottled water, medical oxygen, and replacement filters to remote mountain villages and lowland towns alike. Tents become clinics and water kiosks, points of distribution for both relief goods and public health information. Community volunteers learn to test water pH and turbidity with simple kits, signaling danger when readings exceed safe limits. Local councils organize clean air zones in municipal buildings, using portable partitions and negative pressure units to carve havens of breathable air in the center of ash-choked streets. Industrial responses shift gears. Air purification companies pivot from urban skylines to personal devices, portable purifiers, wearable fan masks with multi-layer filters. Water treatment firms promote gravity-fed, ceramic filters and rainwater harvesting barrels with first flush diverters to shed the initial heavy ash loads. Public spaces, libraries, post offices install vestibules with decontamination showers at entrances, washing ash off clothing and skin before entry. City codes evolve to require roof reinforcements and gutterless designs for future resilience. Research efforts accelerate. Pulmonologists analyze bronchoalveolar lavage samples, tracking the fate of ash particles within lung tissue. Toxicologists map the chemical profiles of ash from different volcanoes, identifying which mineral compositions pose the gravest risk. Hydrogeologists trace ash plumes in groundwater aquifers, modeling the spread of fluorides and heavy metals. Their findings inform mitigation, prioritizing buffer zones around water intakes, deploying activated alumina for fluoride removal, and advising communities on safe well placements. In the months that follow, a new normal takes hold. Air quality indices hover at hazardous levels for days on end, then gradually decline as ash settles or is washed into drainage systems. Reservoir levels recover as treatment plants restore operations. Hospitals discharge patients once reliant on ventilators, their breaths shallow but free of masks. Schools reopen in staggered shifts, each child clutching a freshly laundered cloth mask. Families share chores, tending indoor plants that clean air, checking water filters, monitoring everyone's oxygen saturation on pulse oximeters. Survivors mark anniversaries of the eruption with solemn rituals. Communities gather at the edge of the ash plain for remembrance ceremonies, releasing paper kites into clearing skies. They recount the first moments of relief when sunlight pierced the gray dome, and the first taste of clean water on parched lips. They honor healthcare workers and volunteers who risked everything to clear ash, treat the sick, and restore hope. In these gatherings, the memory of gasping for breath and choking on water finds solace in collective resilience. Epidemiologists compile final tallies. Thousands treated for acute inhalation injuries. Hundreds of chronic cases identified. Dozens of communities relocated due to water contamination. Research papers appear in international journals. Their titles sober: Long-term respiratory outcomes following volcanic ash exposure, fluoride toxicity in post-eruption water supplies, psychosocial impacts of airborne silica. These studies inform disaster preparedness plans worldwide, weaving the lessons of struggle into future protocols. As recovery continues, cities adapt. Public buildings install permanent AVIC systems with ash-resistant filters and multiple intake points. Homes are built with positive pressure airlocks at entrances to keep ash at bay. Water treatment infrastructure gains redundancy. Dual intake channels, sedimentation basins, and real-time turbidity monitors that trigger isolation valves when thresholds are exceeded. Drills and simulations include ash contingencies. Schools teach children to repurpose household materials into emergency masks. The fear of suffocation becomes memory tempered by galvanized readiness. In every healed lung, every spring well that pours clear, a story of struggle and survival endures. Volcanic ash remains a testament to Earth's power over air and water, a reminder that human health rests on the fragile balance of atmospheric clarity and pure hydration. Yet within that balance lies the triumph of collective action. Masks sewn in kitchens, water filters crafted in workshops, protocols written in haste and deployed with care. Each breath reclaimed, each sip drawn from clean water, affirms the resilience of a world shaped by fire, but defined by the determination to breathe free. A silent gray veil descends over forests, fields, and oceans alike, each ash flake drifting downward like microscopic knives. In the sky's muted glow, birds that once painted the heavens in vibrant arcs now struggle to lift their wings, feathers weighed down by glassy grit. Each wing beat sends shards scratching through plumage, lodging between feathers, piercing follicles, and scouring the delicate membrane that seals their respiratory passages. Migratory flocks scatter, their ancient routes erased by the choking air, and many descend into unfamiliar territories, desperate to find open water or ash-free land on which to rest. On the ground, small mammals emerge from burrows into an otherworld of falling dust. Hares and rabbits bound awkwardly through drifts that fill their warrens, their nostrils bristling with abrasive ash. Deer and elk, conditioned to browse open meadows, find blades of grass buried beneath a thick cake of soot. Their digestive systems, built for tender shoots, cannot process ash-coated foliage, leading to malnutrition and lethal digestive wear. After the 1980 Mount St. Helens eruption, Washington fish and wildlife biologists estimated 11,000 hares and 6,000 deer perished under similar conditions, alongside thousands of other mammals trapped in unbreathable gloom. Predators fare no better. Wolves and foxes that once trailed herds across open tundra now struggle to follow buried tracks. Their paws slip on ash-slick surfaces, claws grinding through layers of dust rather than soil. Wild cats, accustomed to stalking prey by sound, find their hearing muffled in the thick air, forcing them to rely on scent vectors that ash particles distort. Every hunt becomes a trial of attrition, and many predators starve as prey vanishes into gray drifts or migrates beyond their territories. Insects, the bedrock of most ecosystems, face an even steeper climb. Butterflies and moths that rely on delicate wing scales for flight find their appendages plastered shut by fine volcanic glass, making every flutter a battle. Bees, essential pollinators in gardens and woodlands, pump their wings against the dust-laden air, only to collapse in puffs of ash when their thoracic muscles tire. Without these insects, flowering plants fail to reproduce, and the trickle of life feeding higher trophic levels slows to a halt. At pond and stream, amphibians emerge briefly to breathe before ash-clogged lungs force them back into hiding. Frogs' permeable skin, once a marvel of hydration, now absorbs acidic particles that burn their tissues. Salamanders, sheltering beneath logs, find their watery refuges scoured by ash-tainted runoff that chills and acidifies breeding pools. Tadpoles hatch in cloudy shallows, only to succumb to oxygen-starved water and abrasive dust settling on gills. Large herbivores attempt to escape the gray expanse. Bison herds push toward distant horizons, driven by instinct to follow greener pastures. Yet grasslands under ash become deserts of dust, their root systems choked. Camels and wild asses trek in search of water, only to find watering holes sealed beneath layers of ash that poison as they dissolve. In some regions, surviving pockets of refuge in wind-scarred valleys offer scant relief, but overcrowding leads to trampling and competition that outstrip the environment's reduced capacity. Birds of prey eagles, hawks, owls are doubly imperiled. They depend on sharp vision to hunt, but ocular lenses become frosted with ash, blurring images and inflaming corneas. Their talons, previously suited to grip slippery prey, now lose traction on ash-slick branches and rocks. Owls, whose silent flight once blessed nocturnal hunts, find their plumage so coated that lift and stealth vanish, forcing them into daylight hunts they are ill-equipped for. Migratory patterns shatter. Shorebirds that charted courses by nights, lit with constellations, now wander blind under a sky that refuses to reveal stars. They fly wind-beaten routes overseas, turned ashen gray, fuel reserves burning as they search for landmarks that no longer exist. Many exhaust themselves, plunging into water only to struggle with gills clogged by sediment. Terns and albatrosses caught in mid-ocean bouts drift helplessly, their salt-washed nests abandoned on islands coated in ash. Some species fare better by fleeing to higher altitudes or latitudes. Mountain goats scale peaks to graze on exposed lichens, their thick coats offering protection against acidic fallout. Marmots retreat into alpine rock shelters, where wind-scoured ledges limit ash contact. But these sanctuaries are finite. Overcrowding compresses resources, and cold at altitude saps energy further when sunlight is diminished. Nocturnal mammals confront new challenges. Bats that navigate by echolocation find ash-laden air scattering sound waves, making prey detection nearly impossible. Their flight membranes, already designed for thin, humid air, become brittle with dust, leading to tears that impair flight. They congregate in cave mouths, where ash drifts make entry and exit treacherous. Inside, guano accumulations mix with ash, creating toxic ammonia vapors that poison them from within. Insect migrations falter as well. Monarch butterflies that once winged through open skies in multitudes now drift aimlessly in gray clouds, their cardio-muscle strength flagging when every breath demands more effort. Locust swarms, driven by population pressure, settle en masse on shrubs and crops, but the vegetation is laden in ash, offering no sustenance. These insects perish in collective masses, becoming brittle carcasses that rattle in the wind, seeding outbreaks of disease in scavengers that feed upon them. Small mammals attempt to burrow deeper into the soil to evade the choking air, but the ash layer acts as impermeable concrete. Voles tunnel within the subnivean zone, only to find the insulating snow replaced by an ash crust that cuts off oxygen flow. Their labyrinthine networks collapse under the weight, trapping them underground. Shrews that once hunted through leaf litter find both litter and soil suffocated, forcing them onto bare ash, where predation by birds and mammals increases. Rodents in urban landscapes turn to scavenging. Rats and mice invade basements in search of any food not covered by ash. Their populations explode in the chaotic mix of decomposing refuse and scattered grain stores. Yet with disease pathogens also proliferating in the ash-stained environment, zoonotic threats rise. Plague-carrying fleas jump from rodent hosts to human victims in cramped shelters, where ash invades water supplies and sanitation fails. Carnivorous mammals reliant on fish and shellfish fare no better. Otters and seals that hunt in rivers and along coastlines find waterways transformed into muddy gruel. Their whiskers, once attuned to vibrations in clear water, register only sludge. Fish kills become mass strandings as gills clog with sediment. Coastal bears, drawn by marine carcasses, ingest toxic species that bioaccumulate ash-borne heavy metals, leading to neurological impairments that mirror human brain pathologies under toxic exposure. Large carnivores, bears, big cats, wolves test the limits of their adaptability. Some shift to omnivory, digging for tubers or scavenging ash-coated berries. But these food sources often fail to meet caloric demands. Denning bears delay hibernation in hopes of finding prey, while others abandon dens and wander in weakened stupors. Cubs in waiting die as mothers lack reserves and cannot secure safe dens free of ash infiltration. Engineered wildlife corridors become lifelines, man-made gaps in urban zones where vegetation is cultivated beneath protective canopies. But these artificial oases are few and often too small to sustain viable populations. Corridor endpoints become traps, where animals congregate only to find no further way out of the ash-draped cityscapes that encircle them. Ecosystem collapse ripples outward as keystone species vanish. Pollinators die, herbivores starve, predators retreat or perish, and scavengers spread disease. Insects that aerate soil cease to burrow, leading to compaction and further erosion. Seeds once buried in nutrient-rich humus lie exposed to acidified rain, rotting before germination. Forest regeneration halts. Grasslands turn gray and brittle. In open water, planktonic feeders face a parallel exodus. Krill swarms disperse when ash shades sunlit surface layers, collapsing food webs that sustain whales and seabirds. Fish larvae that drift in plankton blooms find no sanctuary. Their mortality rates climb. Marine mammals, dolphins, whales, seals must travel farther in search of food, often entering warmer waters that weaken their cold-adapted physiology. Conservationists scramble to provide emergency feed. Ornithologists orchestrate bird rescues, washing ash from feathers and feeding nutrient-rich slurries. Insectariums and wildlife rehabilitation centers strain under the volume, isolating individuals in filtered air chambers. Successes are few and localized. Most animals are too widespread to save at scale. Over time, the ash layer thins and ecological feedbacks begin to shift. Rare pockets of untainted habitat, wind-swept mountain ridges, geothermal hot springs, ash-cleared river gorges become sanctuaries for recodify. Genetic refugia in these strongholds harbor alleles for ash resilience, tougher wings, stronger lungs, acid-tolerant digestive enzymes that slowly spread through recovering populations. When the skies finally clear, the survivors emerge into a changed world. Bird populations return along restored migratory corridors marked by newly planted windbreaks. Mammal herds reclaim grasslands regrown on ash-fertilized soils. Insects reestablish pollination networks, seeding floral recovery. Yet the memory of the great exodus endures in migration maps redrawn, in genes selected for endurance under gray skies, and in the whispered cautionary tales passed among species that learned, at last, the price of surviving in an ash-draped world. A sudden tremor shivered through the tropics in April 1815, rippling across the island of Samoa as if the earth itself had taken a shuddering breath. Villagers heard distant roars and felt the ground pulse beneath their feet, a prelude to the cataclysm to come. By dawn, Mount Tambra's summit had vanished. Its peak collapsed into a massive caldera. Columns of ash and gas shot skyward in a pillar that pierced the stratosphere, blotting out the sun in a matter of hours. Lightning flickered through the plume's inky heart, each flash igniting fresh pockets of dust and fury. Within days, the sky above the Dutch East Indies was a dull orange haze. Locals called it smoke night, when day fell into an unnatural dusk. Ash rained onto villages in a relentless drizzle, coating roofs, fields, and waterways in fine, glassy grit. By the week's end, roofs bowed under the heavy, damp blanket of silt. Children peered out from shuttered windows, their breaths shallow and wary as parents struggled to clear doorways before the next downpour. Beyond Samoa, the pallor spread across the globe. Observers in India noted sunsets washed in lurid reds, Ships at sea reported a crimson sun that never set fully. Sailors wrote of days when compasses spun aimlessly, their instruments blinded by abrasive dust. In Batavia and Jakarta, merchants found their goods coated in ash, rice husks mixed with gray grit, making every grain heavy and unfit for trade. The world's arteries stuttered under a veil that knew no borders. When summer arrived in the northern hemisphere, it carried frost on its heels. In New England, ice formed on ponds in June. Farmers found snow in July that clung to haystacks and wilted corn. Gardeners harvested green tomatoes, their leaves blackened by cold. In Europe, the Rhine froze on midsummer nights, a spectacle unseen in living memory. Markets emptied as potatoes rotted underground and grain fields turned to stony stumps. It was a year the planet forgot summer, an event soon termed the year without a summer. Tamra's eruption ranked as the most powerful of the past millennium, pulverizing 37 to 45 cubic kilometers of rock into the atmosphere in a single blast. The ensuing sulfate aerosols reflected sunlight back into space, cutting surface temperatures by an estimated half to 1 degree Celsius in 1816. The drop may seem slight, but it was enough to push climate systems past critical thresholds. Monsoons faltered, rain belts shifted, and the delicate dance between land and sea broke its cadence. Harvest failures triggered cascading crises. In Switzerland, crop yields fell by half. In Ireland, famine gripped the countryside as potatoes blackened in the field. Livelihoods vanished overnight as livestock perished from hunger and cold. Peasants migrated toward cities in desperation, seeking work that did not exist. Revolts simmered in regions where hunger bred anger, and charity ran out faster than rations. Cultural fallout rippled through art and literature. Poets wrote of ashen moons and silent skies. Their words mirror the choking hush that fell upon the world. Painters dabbed canvas with muted grays and browns, capturing landscapes under perpetual twilight. Chronicles of the time tell of children learning to recalibrate clocks by ash depth rather than hours of light, as if time itself had been buried beneath the volcanic veil. These events etched lasting patterns in climate records. Tree rings from Europe and North America show markedly stunted growth in 1816, a fingerprint of cold that persists in botanical memory. Ice cores extracted from Greenland reveal sulfate spikes corresponding to Tambra's plume, a global ledger of ash and acidity. Geologists regard these layers as markers for one of human history's most traumatic climate shocks. Yet Tambora was merely the most recent chapter in Earth's fiery autobiography. 74,000 years earlier, an even greater tempest erupted at Mount Toba in Sumatra, casting off a caldera 8 times the size of Tamra's. That super-eruption expelled roughly 2,000 cubic kilometers of magma, eclipsing any atomic blast in sheer scale of devastation too. The planet shuddered under a veil of aerosol and ash that may have lingered for a generation, ushering in a volcanic winter of unprecedented magnitude. Paleoclimatic data point to a global temperature plunge of up to 3 to 5 degrees Celsius in the aftermath of Toba's blast. Polar ice cores record elevated sulfate layers, and marine sediments show disrupted plankton blooms as sun-starved oceans lost their shine. Mountain glaciers accelerated their advance, while rain belts retreated toward the equator. In many regions, rainfall sagged into years of drought, turning green savannas into drifting dunes. For early humans, the Toba super-eruption posed an existential threat. Genetic bottleneck models once suggested that human populations plummeted to as few as a few thousand individuals, narrowing Homo sapiens' diversity to a fragile thread. Yet recent archaeological discoveries at Ethiopia's Shinfa Metama 1 site tell a more hopeful tale. Early humans in the Horn of Africa endured the ashfall, adapted their diets to fish from receding pools, and refined hunting tools to match the altered landscape. Why? Microscopic shards of volcanic glass embedded in sediment layers at Shinfa Metama offer precise timestamps for the eruption's reach into Africa's Rift Valley. There, people gathered around riverbanks, catching fish as waterways shrank and gathering tubers in wetlands. Projectile points found at the site hint at the earliest forms of archery, a technology that shifted reliance from herd hunting to more versatile subsistence strategies. Rather than vanishing, these populations thrived in micro-refugia, pockets of water and vegetation buffered against the worst of the ash suffocation. Seasonal rivers, or blue highways, guided movement through an otherwise ash-choked world, helping humans maintain gene flow and cultural exchange, even as climate belts contracted. This resilience underscores the adaptability of our ancestors, their ingenuity in the face of collapse shaping the course of our species. Toba's echoes are not merely anthropological footnotes. They intertwine with megafauna extinctions that reshaped ecosystems worldwide. In South Asia, diminutive populations of elephants, rhinoceroses, and deer endured in forest pockets, only to fade in subsequent millennia. In Sahul, the supercontinent joining Australia and New Guinea, marsupial giants like Diprotodon disappeared, their bodies never to walk the earth again. The confluence of abrupt cooling and human predation may have tipped these species into oblivion. By contrast, Africa's megafauna show a more gradual turnover, perhaps because species there co-evolved alongside early humans and climatic fluctuations. Elephants, hippos, and crocodiles retain deeper genetic bottlenecks, living records of the struggle through eruptions and ice ages. Their genomes carry alleles that hint at survival strategies under periodic cooling, inscribing volcanic winters into the DNA of living giants. Back in modern times, Tambra's legacy remains a touchstone for understanding climate risk. The 1991 eruption of Mount Pinatubo injected 20 million tons of sulfur dioxide into the stratosphere, cooling global temperatures by about 0.5 degrees Celsius for 2 years. An echo, albeit smaller, of Tambra's might. These modern events remind us of the stratosphere's sensitivity to aerosol forcing and the swift planetary scale responses that can follow. Today, volcanologists and climate modelers monitor active supervolcanoes like Yellowstone and Toba caldera with intense scrutiny. Seismic networks measure magma chamber inflation. Gas sensors track sulfur flux. Satellite instruments gauge aerosol, optical depth. Early warning systems aim to provide months or years of notice before a caldera ruptures. But the threat remains real. A supereruption could inject enough ash and sulfate to trigger another global winter, testing society's resilience on an unprecedented scale. Humanity's past brushes with volcanic winter inform our present preparedness. Food reserves, seed banks, and diversified crop portfolios seek to buffer harvest failures. Geopolitical collaborations on disaster relief and humanitarian corridors echo the caravans that once moved grain across famine-stricken Europe in 1816. Public health protocols for respiratory crisis trace lineage back to the wooden masks and vinegar-dampened cloths of Tambora survivors. Even as science advances, cultural memory preserves warnings. Folk songs in alpine villages tell of ice on sunlit days. Japanese haikus lament ash-strewn fields. Calendar festivals mark ash anniversaries, days when communities pause to remember the skies lost to smoke and the earth starved of warmth. Elders recount childhood tales of white mornings that were never winter, of wells choked by grit, of hunger that drove families to riverside refuge. In the stillness of a darkened sky, the Toba and Tambora eruptions speak across time. They remind us that Earth's fury can arise without heed to human borders, that a single volcanic heart can cold the planet in a matter of hours. Yet within these ancient cataclysms also lies a testament to resilience, of microbes that survived in sealed lakes, of plants that sprouted on fresh ash, of humans who fished receding waters and wove new tools in the ashen gloom. As we drift into the era of renewable energy, climate stabilization, and planetary stewardship, The echoes of ancient volcanic winters guide our path. They teach humility before forces that dwarf our cities, that can dim our sun and chill our fields. But they also teach hope, that even in the deepest chill, life finds cracks to kindle warmth, ingenuity that draws breath from dust, and communities that rise from ruin to trace new routes across the sky. The rise and fall of human societies have always been entwined with the moods of Earth's climate. Among the most abrupt and devastating of these climate episodes have been volcanic winters, periods when explosive eruptions injected vast quantities of ash and sulfurous gases into the stratosphere, dimming the sun and plunging global temperatures for years. History records several such events that unraveled the foundations of empires, from the Bronze Age collapse after the Thera eruption to the famines and social upheaval triggered by Toba in 1815. By examining these past disasters, we uncover not only the vulnerabilities of agrarian civilizations, but also vital lessons for our global society, still at the mercy of forces beneath the crust. Long before written chronicles, around 1600 BCE, the Minoan civilization on Crete thrived in palaces of white marble and frescoed halls. In 1257 CE, Indonesia's Samalas volcano erupted from what is now Mount Rinjani on Lombok, ejecting more than 40 cubic kilometers of magma and ash into the stratosphere. Contemporaneous chronicles from China to Europe report freezing summers, failed harvests, and widespread famine. Tree rings across the northern hemisphere show dramatically suppressed growth, reflecting temperature drops of up to 1 degrees Celsius for several years afterwards. In Europe, this period saw peasant revolts as bread prices soared, while in the Holy Roman Empire, monasteries recorded mass mortality and abandoned lands. The social upheaval set the stage for later conflicts, fracturing feudal allegiances and reshaping medieval politics across 2 continents. Then came Loki in Iceland, whose 1783 to 1784 fissure eruption released some 120 million tons of sulfur dioxide over 8 months more than Toba, the 1815 blast. A dense haze of sulfuric aerosol spread across northern Europe, causing severe acid rain and crop failures. In France, harvest yields plummeted by half, fueling food riots that foreshadowed the Revolution of 1789. In England, respiratory illnesses surged, and sheep losses reached 78%. Within Greenland's ice cores lie the chemical signatures of this haze, a stark reminder that even remote eruptions can imperil empires half a world away. The single most notorious volcanic winter in recorded history followed Tambra's colossal 1815 eruption on Sumbawa. Over 150 cubic kilometers of material blasted skyward left a caldera 4 kilometers wide. Sulfate aerosols circled the globe, reflecting sunlight and driving average temperatures down by up to 1 degrees Celsius for more than a year. In New England, dairy farmers watched ice form on ponds in June. In Europe, the Rhine froze in July. Rice harvests in China failed. Europe endured mass starvation and typhus outbreaks. Toba's year without a summer serves as both a geographic and social boundary marker one hemisphere, never really knowing the warmth of its sun. What unites these calamities is the fragility of pre-industrial food systems. Without synthetic fertilizers or long-distance refrigeration, agrarian societies depended entirely on predictable seasons. A shortening of the growing season by even a few weeks could erase a year's worth of cereal production, triggering famines that rippled through trade networks. Centralized empires, with their vast bureaucracies and specialized elites, found themselves unable to redirect grain to desperate peripheries when production collapsed. In some cases, like the Song dynasty in China, large-scale public granaries and early disaster relief averted total societal collapse, highlighting the importance of adaptive governance. Patterns emerge when we examine the archaeological and written records side by side. The Bronze Age collapse around 1200 BCE, often attributed to a constellation of invasions and economic factors, may also have coincided with volcanic winters triggered by eruptions like theras. Sediment cores and dendrochronology hint at multi-year droughts and cold spells that would have undermined the great palaces of Mycenae and Hattusa. Once these states lost their agricultural base, their capacity to project power vanished, opening the door for migrations and conflict that reshaped the map of the ancient Near East. The decline of the classic Maya civilization in the 9th century CE likewise interweaves climate stress with societal breakdown. Prolonged droughts, possibly exacerbated by volcanic aerosols from eruptions in the Mexican, trans-Mesoamerican volcanic belt, led to the abandonment of urban centers in the southern lowlands. Reservoirs dried, terraces crumbled. Once sacred pyramids became overgrown ruins. While local factors like warfare and resource depletion contributed, the overarching driver appears to have been a sustained interruption of rainfall and sunlight. A volcanic winter writ small across a millennium. Such collapses teach hard truths. First, societies dependent on monoculture and single-crop kingdoms are extremely vulnerable to even short-term shocks. Second, centralized authority must remain both flexible and transparent to mobilize resources swiftly when climate anomalies strike. Third, diversification of crops, energy sources, and trade relationships builds resilience. Iron Age societies that supplemented grain with fish, tubers, and stored fats weathered cold years better than those reliant on wheat fields alone. The lessons carry stark relevance for today's world, still riding the sharp edge of climate variability. Modern agriculture, while far more productive, also hinges on predictable weather patterns and uninterrupted sun. A super-eruption akin to Tambora would test global food reserves, disrupt supply chains, and strain emergency response systems to the brink. Even a half-degree Celsius drop can imperil tropical rice belts, North American maize production, and Northern European dairy yields. Yet we possess advantages our ancestors could only imagine. Crop diversity, global shipping networks, satellite early warning systems, and international relief frameworks. Grain stored in silos across continents can be rerouted to famine-stricken regions. Advanced climate models can predict aerosol dispersion months in advance, allowing preemptive action. Health systems can deploy antiviral stockpiles and respiratory therapies. Communication technologies keep populations informed when ink on parchment letters once took months to arrive. Still, these assets must be continually maintained and scaled. Recent volcanic episodes remind us how quickly ash can ground aircraft, disable satellites, and degrade air quality to hazardous levels. Emergency planning must account for ash removal, filter distribution, and the potential for extended power outages. Agricultural extension services should promote heat and cold-tolerant crop varieties and support small-scale farmers in diversifying land use. Water management must anticipate acid runoff and develop rapid neutralization protocols. The collapse of past empires underscores the importance of redundancy. Just as Bronze Age kingdoms crumbled when their granaries emptied, modern financial, energy, and food systems can falter if built on lean efficiency rather than robust backup. Redundant power grids, multiple shipping routes, and decentralized food storage reduce the risk that a single event can cascade into systemic failure. Policymakers must weigh the costs of redundancy against the existential risk of complete breakdown under extreme climate shocks. Beyond infrastructure, psychological preparedness plays a crucial role. Historical accounts reveal how fear and rumor fuel social unrest in volcanic winters. Charitable impulses give way to hoarding, and communal bonds fray under hunger. Cultivating social trust, ensuring transparent information flow, and reinforcing community networks build social capital. Citizens who trust authorities and one another are more likely to observe rationing, share resources, and volunteer in relief efforts when daylight dims. Cultural memory of ancient disasters can both help and hinder. Folk tales of ash years surviving in alpine songbooks or Himalayan oral histories remind communities of past resilience. Yet cultural amnesia, forgetting the perils of volcanic winter in the glow of modern comfort, can breed complacency. Educational programs should integrate historical case studies into curricula, linking geology with civic planning and geology with agricultural science. In the final analysis, the end of empires in the wake of volcanic winters speaks to a universal vulnerability. No human domain, however grand, stands immune when sunlight falters. But these echoes from Tambora, Toba, Somalis, and Laki also testify to a profound human capacity for adaptation. Empires rose again after their ashes settled. Societies reinvented their economies and belief systems, and technologies advanced to mitigate future risks. By carrying forward these lessons through resilient infrastructure, diversified economies, transparent governance, and a vigilant spirit, our global civilization can hope not only to survive, but to thrive, even under skies darkened by the breath of fire. A low, bruised light filters through a sky thick with suspended ash, where the sun remains forever, a pale disk half hidden behind a swirling veil of soot. Day and night blur into endless twilight, and each breath draws in microscopic shards of volcanic glass that hang like smoke in the air. Under decades of this ash-laden canopy, the very rhythms of life shift. In what historians will one day call the Age of Darkness, human culture and survival transform beyond recognition, reshaped by a sky that refuses to clear. Cities once oriented around open plazas and sunlit boulevards now recede behind monumental halls built to trap the flicker of fire. Architects carve inward-facing domes lined with polished metal, reflecting the glow of hearths and lanterns into great chambers where people gather to live, work, and worship. Streets narrow into covered arcades, ash galleries, roofed with translucent ceramics that diffuse the weakest light into a perpetual dusk. Skylines vanish behind towers of soot-resistant stone, their windows a mosaic of smoked glass and mica plates, admitting only a fraction of the outside gloom. Light becomes the most precious currency. Coal and wood supplies dwindle under relentless ashfall. In their place, subterranean farms tap geothermal heat rows of mushrooms, algae vats, and hydroponic greenhouses glowing under bioluminescent lamps. Inventors perfect low-energy LEDs powered by fuel cells that convert ambient heat into electricity. Every household installs sun simulators, ceiling arrays of amber LEDs programmed to mimic the sun's arc, regulating circadian rhythms for work, rest, and ritual. Agriculture retreats beneath the ground. Farmers dig deep into lowest soils, mixing ashen top layers with compost to create gray loam, seeded with barley strains adapted to low light. Fungi become staples. Oyster mushrooms grow on ashwood substrates in abandoned subway tunnels, while spirulina thrives in indoor tanks where sunlight never penetrates. Lab-grown protein, once an experimental novelty, becomes a dietary necessity, cultured on volcanic minerals and engineered to provide vital vitamins missing when fields no longer yield. Clothing transforms too. Fabrics woven with reflective fibers, titanium, doped silks, and aluminized cottons trap every photon of artificial light, insulating bodies against the ceaseless chill. Hooded cloaks lined with shearling resist stinging ash storms, and personal air filtration odes channel purified air through charcoal and electrostatic filters. Children learn at an early age to seal clothing layers under ash caps, and to recognize the hush of approaching storms by the soft crunch of falling grit. Time itself splinters. Without reliable sunrise and sunset, communities adopt polyphasic cycles, short bursts of work, and rest around the clock. Schools meet in rotating shifts under bright lantern arrays. Factories hum continuously, staffed by teams that stagger their hours so that fresh hands always press controls. Calendars shift from solar reckoning to light logs, where days are counted by hours of usable glow rather than orbital cycles. Birthdays and festivals migrate to the bright weeks of thinned ash, creating new holidays that honor returning light. Psychology adapts or unravels. Seasonal affective disorder intensifies into a baseline despair for those without access to regulated light. Therapists prescribe spectrally tuned lamps to restore serotonin and melatonin balance, while ceremonial dark retreats equip participants with guided meditation to withstand the gloom. Storytellers spin myths of an ever-receding sun dailies of ancient heroes who climbed ash-hewn mountains to strike flints at the sky's edge, rekindling dawn in the dark. In these blackened ages, art and religion find new forms. Caves carved into hillside banks become sanctuaries, their walls painted in luminescent pigments that glow under phosphorescent dust. Priests conduct ceremonies around eternal flames, sun cells, their choreographed dances invoking lost seasons. Music shifts to lower registers. Long-bowed cellos, bass flutes, and human chants vibrate through ash-lined cathedrals, resonating in chambers where every pulse of sound seems amplified by the hush outside. Literacy surges as oral traditions falter under the weight of collective anxiety. Scribes copy illuminated manuscripts by candlelight, using ash-proof inks and silver leaf to reflect every stray glow. Libraries become vaults of human memory, guarded against ash infiltration with hermetic seals. Scholars study past volcanic winters, from Tambora's year without a summer to Toba's millennia-old super-eruption-seeking patterns in tree rings and ice cores that might guide survival strategies for the long darkness ahead. Social order strains under resource scarcity. Centralized governments erect light zones around power infrastructures. Districts prioritized for electricity and filtered air. Citizens queue for ration cards that allocate grams of coal, liters of filtered water, and hours of public lighting. Black markets thrive in the shadows, trading contraband kerosene, portable filters, and illicit seeds flown in by smugglers who brave ashbound no-fly zones. Migration patterns redraw the map. Coastal cities, where persistent ocean breezes thin the ash layer, become Lifeline's oases of comparatively clear air. Populations swell as refugees pour in, triggering tension over harbor space and freshwater access. Inland, desert oases fed by geothermal springs attract settlers who master greenhouse farming in bubble domes. The networks of roads and railways crumble under ash accumulations, pushing migrants onto footpaths scraped through drifted mounds, gray highways, carved by necessity. Trade routes collapse and re-emerge along new corridors. Pack caravans traverse mountain passes where wind scours ash from high ridges, creating ephemeral white lines free of grit. Merchant guilds guard these passageways, guiding caravans of dried food, medicinal herbs, and shimmering mica panels for light harvesting. Maritime routes shift to equatorial seas, where sunlight and air currents remain strongest. Technology races to outpace the dark. Aerostat flotillas ascend above the ash sheet, tethered balloons carrying solar panels that power relays for global communications and GPS rebroadcast. Satellites fitted with ash-resistant coatings continue to orbit, mapping aerosol thickness and guiding relief flights that parachute supplies into isolated communities. Engineers design hybrid nuclear geothermal reactors to generate heat and light in subterranean bunkers, the glow transmitted by fiber optic cables to surface dwellers. Education evolves into survival training. Curricula blend botany with indoor farming, mechanical engineering with filter maintenance, and psychology with ash storm response. Children learn to test water pH for fluoride contamination. They memorize emergency protocols for razor-sharp downbursts. Universities establish ash studies departments, researching the abrasive properties of volcanic glass and developing new composite materials, from transparent ceramics to self-heating fabrics that define the era as industrial base. Health systems strain but innovate. Mobile clinics deploy on tracked vehicles equipped with HEPA chambers to conduct respiratory screenings. Telemedicine flourishes as doctrine. The few clear days used to calibrate drones with sterilized airbags, delivering inhalers, antibiotics, and vitamin D supplements. Immunologists study survivors for genetic markers of cold and hypoxic endurance, hoping to bolster populations vulnerable to long-term lung fibrosis and osteoporosis. Ecosystems push through the ashen gauntlet. Pioneer plant species lichen, moss, and algae colonize paving cracks, breaking down ash into fertile silts. Insect populations shift toward resilient beetles that feed on decaying wood and ash-tolerant fungi. Predatory birds adapt to hunting by sound in dim air, their winged feathers evolving greater abrasion resistance in a few generations. Fish species in equatorial lakes thrive on nutrient pulses from ash runoff, forming fish farming opportunities for isolated communities. Cultural memory crystallizes. Ash layers become geological markers of shared trauma, a gray horizon etched across sediment cores. Myths recount ancestor heroes who carried glowing embers up volcanic slopes to relight the sun. The stories, first sung around flickering hearths, pass into hymns and cycles of seasonal drama. Archives preserve first-person accounts, letters home, vision diaries, maps drawn under lantern glow. These records inform future generations of the perils that lie in Earth's molten heart. After decades, the veil finally begins to thin. Winds shift patterns. Rains wash the last of the aerosols from the stratosphere. Sunlight returns in a muted amber, building back to crisp white over seasons. Crops planted in gray loam yield golden harvests once more, while sun season festivals mark the rebirth of light. Survivors emerge blinking into the radiance, their lungs strengthened by years of filtered breathing, their skin faintly stained by ash, their hearts steeped in the memory of darkness. But the age of darkness leaves legacies embedded in every aspect of human life. Architecture retains ash-proof design. Clothing carries reflective fibers. Calendars still include dark weeks, honoring decades of dim skies. Genetic studies trace adaptations for low light vision and cold tolerance. Political systems institutionalize resource fairness to avert famine when harvests falter. Cultural expressions bear the motifs of ash and ember, a symbol of life forged in gloom. In the slow dawn that follows, humanity carries forward both caution and courage. The lessons of the ash-shrouded centuries of architectural resilience, communal solidarity, and relentless innovation become cornerstones of a new era. And as the world steps into renewed sunshine, the age of darkness stands as testament that even under the deepest veil, creativity and cooperation can kindle a spark bright enough to light the path home. A pale glow seeps through the ash-choked sky, tinting the horizon in muted silver. Beneath this gentle light, the world is quiet, so quiet that the faint drip of water off a jagged ash shard echoes like a distant bell. Decades have passed since the skies first darkened, and the relentless fall of glassy dust has finally begun to wane. In its retreat, the ash has settled into an uneasy patina across fields, forests, and wetlands. Yet the earth, once smothered, now trembles with the tiniest stirrings of recovery. On exposed volcanic slopes, the first pioneers emerge. Microscopic algae and cyanobacteria colonize bare ash, their cells casting a faint green haze against the gray. These resilient microbes produce sticky biofilms that bind the ash grains together, creating fragile crusts on the surface. As they photosynthesize, they exhale oxygen and trap moisture, gradually softening the harsh layers overhead. Tiny communities of bacteria transform volcanic glass into silica-rich clays, unlocking nutrients for the next wave of life. Within months, lichens, those symbiotic unions of fungus and alga, take hold on rock outcrops and coarse pumice deposits. Their intricate thalli spread like fractal mosaics, each breath co-regulated by fungus and photosynthetic partner. Their acids etch the ash, dissolving feldspar in basalt to release potassium, calcium, and magnesium. These minerals trickle down through microscopic fissures, seeding the birth of soil. Step by slow step, a thin veneer of life glues itself to the cold rock of devastation. Mosses follow, carpeting sheltered pockets with velvety cushions of emerald green. They trap leaf litter blown in on gentle winds and capture dew that glistens each dawn. Their dense mats insulate the ash layer, preventing extreme temperature swings that would otherwise fracture nascent soils. Beneath the moss, tiny invertebrates, springtails, and mite, like creatures, commence their silent work, chewing through decaying fungal filaments and breaking down organic matter. Their fecal pellets weave organic threads into the emerging substrate. As the first whispers of soil accumulate, herbaceous pioneers push through, grasses with fibrous roots and hardy forbs whose seeds drifted in on ash-laden breezes. Their roots bore shallow channels that let rainwater infiltrate deeper layers, reducing surface erosion and flushing soluble minerals downward. With each growing season, more organic matter enriches the ground as plants die back and decompose. The landscape, once featureless and sterile, now hums with the subtle complexity of a regenerating biome. Mycorrhizal fungi thread through these young root systems, forging alliances that extend the reach of plants into the ash-stained earth. Their hyphae tap into mineral pockets beyond roots' capacity, exchanging nutrients for carbohydrates produced by leaves. This subterranean network knits plants into communal endurance, enabling shrubs and trees, birches, willows, and alders, to take root in the fractured terrain. These fast-growing species, adept at colonizing disturbed soils, form the first woodlands in a century. Under the nascent canopy, insect life surges. Caterpillars munch fresh leaves. Beetles tunnel in decaying wood. Pollinators flit among pioneering wildflowers. Dragonflies patrol shallow pools carved by meltwater, their larvae shaping aquatic food webs. Even the quiet streams, once clogged with ash, clear as sediment settles behind makeshift gravel bars. Fish return to spawn in the riffles, tracing the calendar they have known for millennia. Birdsong, long absent, drifts again through the trees. Warblers flit among budding willow catkins. Thrushes drum on hollow logs to draw mates. Raptors, peregrines, and hawks perch atop ash-smoothed ridges, scanning for rodents that burrow beneath the grassy lawns. Their cries echo across the recovering valley, a herald of reawakening predator-prey balances. Mammals venture back into foothills once sealed by ash. Voles and mice scurry through grass stems. Their tunnels further aerate the soil. With them come foxes and weasels, chasing agile forms through the undergrowth. Herds of deer slink among young groves of birch and aspen, browsing tender shoots that taste of renewal. Even elusive lynx ghosts of the forest reappear, drawn by the scent of life returning. Wetlands, too, heal in gentle arcs. Reed beds colonize silted shallows. Cattails stand in forming marshes where frogs breed in the warming sun. Beavers, ever the ecosystem architects, fell saplings to dam slow-moving streams. Their ponds trap sediment and enrich soils with leaf litter, expanding the watery sanctuary for dragonfly nymphs and spawning fish. Over generations, these pioneer woodlands yield to mixed forests. Oak and maple seedlings draw strength from the richer soils left by decades of decay. Their deep roots fracture compacted ash layers, exposing new minerals. The forest floor becomes a tapestry of ferns, mushrooms, and leaf mold, an emollient that cradles new life and softens the legacy of ash. Beneath the broadleaf canopy, a chorus of life unfolds. Insects return in abundance. Butterflies sip nectar from woodland flowers. Arc beetles carve galleries within rotting trunks. Ants sculpt soil galleries in the soft earth. Each creature, however small, plays a role in cycling nutrients and turning ash into living ground. Bird populations diversify. Woodpeckers drum on decayed timber, carving holes for nest cavities. Swallows skim dust-free puddles, feeding on the re-emergent insects. Thrush families scout mossy banks for worms, teaching fledglings to forage beneath sunlit gaps in the leaves. Large herbivores resume seasonal patterns. Elk follow green flushes in spring. Moose find aquatic chutes in widening marshes. Their grazing opens glades that sun-warmed wildflowers colonize, creating a mosaic of meadows within the forest. Predators re-establish territories. Wolves led packs across recovering ranges, restoring the rhythm of chase and escape. With time, the ash falls into memory rather than presence. Where thick drifts once suffocated life, thick humus now supports ancient tree anchors. Soil profiles display layers of dark organics above pale ash seams, archaeological signatures of a bygone age. Earthworms, reintroduced by birds and mammals, aerate and mix these layers, filling the soil with tunnels that breathe water and life. Human communities, returning to abandoned homesteads, discover soils enriched by volcanic minerals. They plant orchards and nurseries, built within protective hoop houses. Barley, rye, and root vegetables flourish in the loamy ground, born of ash and microbe toil. Wild mushrooms, morels, chanterelles sprout among leaf debris, harvested by cautious hands. Fishermen net trout from crystal pools that glimmer in renewed sunlight. Cultural revival echoes ecological return. Festivals celebrate the anniversary of the first green shoots. Songs honor ancestral lessons of patience and perseverance. Knowledge of pioneer plants, bittercress, fireweed, lupin passes from grandparents to grandchildren as vital lore for healing land and body. As forests mature, microphones pick up dawning choruses beneath green canopies. The wind stirs leaves that whisper secrets of endurance. Eagles ride thermal currents again, their wings silhouetted against cerulean skies freed from ash. Mountainsides shimmer with wildflowers in spring, reminding all that life's promise endures even after the fiercest winters. In the end, the fragile rebirth stands as testament to the Earth's boundless resilience. Decades of darkness gave way to centuries of green, each generation building upon the quiet labor of its predecessors. The ash that once threatened to silence life became the bedrock of renewal, its nutrients transformed through microbial alchemy into fertile soils. And in that recovered land, humanity finds humility and hope. Lessons of patience and cooperation echo in every regenerated brook and budding sapling. For in the slow dance of ecological succession, we glimpse a truth older than empires, that life, though fragile, carries within it the power to renew itself even from the gray ashes of catastrophe. Volcanoes stand at the intersection of destruction and creation, wielding power to raise landscapes one moment and to weave new ones the next. Fire and ash pour from their vents in cataclysmic eruptions that can flatten forests, reshape shorelines, and darken skies for years. Yet in the wake of this violence, life often finds a foothold in fresh soils born of cooled lava. Over geologic time, these dual roles have sculpted continents, nourished ecosystems, and drawn human civilizations to their slopes. Deep within Earth's mantle, heat and pressure conspire to melt rock into magma. Tectonic plates drift atop this molten layer, converging at subduction zones, rifting apart at divergent boundaries, or sliding over mantle hotspots. Where plates collide, one dives beneath another, triggering partial melting that spawns stratovolcanoes like the Andes. Where plates pull apart, such as the mid-Atlantic ridge, magma wells up, building basaltic shields that widen ocean basins. Over millions of years, these processes forge mountain chains, island arcs, and oceanic plateaus. When a volcano erupts explosively, it releases ash and gases high into the stratosphere. Pyroclastic flows surge down flanks at hundreds of kilometers per hour, incinerating everything in their path. Lahar's volcanic mud flows cascade through valleys, uprooting trees and burying villages. Ashfall blankets farmlands, collapsing roofs under its weight and choking waterways. The immediate aftermath is one of ruin. Crops die, water sources foul, and communities face famine and displacement. Yet the very same eruptions sow seeds of renewal. As ash settles and rain begins to wash it into the soil, tiny shards of volcanic glass weather into clay minerals rich in potassium, calcium, and magnesium. These nutrients feed the first microbial pioneers, cyanobacteria and lichen, that colonize bare rock. Their biofilms trap moisture and create pockets of nascent soil. In centuries, mosses and ferns carpet the landscape, followed by grasses and shrubs whose roots knit the ash into richer ground. Volcanic soils, often called Andisols, rank among the most fertile on Earth. In Java and the Philippines, rice terraces cling to volcanic slopes of Mt. Mayon and Mt. Pinatubo. In Hawaii, sugarcane and coffee flourish on the nutrient-dense loams derived from long-cooled lava. In Italy's Campania region, vineyards thrive on volcanic tuff above Monte Vesuvius. The iron, phosphorus, and potassium released by eruptions stimulate plant growth far more vigorously than many sedimentary soils allow. Beyond agriculture, volcanic activity delivers metals and minerals essential for industry. Magmatic fluids concentrate gold, copper, and molybdenum into ore deposits near volcanic arcs. The porphyry copper belts of Chile and Indonesia underpin global electronics manufacturing. Geothermal heat from shallow magma chambers powers renewable energy plants in Iceland, New Zealand, and California's Geysers Field, where steam drives turbines to generate carbon-free electricity. Island chains owe their very existence to volcanoes. The Hawaiian archipelago began as seamounts fed by a mantle hotspot. Over time, successive eruptions built islands that have hosted endemic flora and fauna. In Japan, the Kuril Islands trace a volcanic arc over a subduction trench. In the Mediterranean, Santorini's Minoan eruption around 1600 BCE reshaped sea levels and influenced Bronze Age trade networks. Each island emerges from the sea as a testament to Earth's fiery creativity. At continental scale, volcanic mountain ranges bind entire regions into distinct physiographic provinces. The Cascades of North America stretching from British Columbia to Northern California line, a subduction zone that has built Mt. St. Helens, Mount Rainier, and Mt. Hood. The Andes, the world's longest continental chain, define South America's spine, their peaks fed by the Nazca Plate diving beneath the continent. Over time, weathering of volcanic rocks feeds rivers that build vast alluvial plains. Volcanoes have also reshaped the ocean floor. Mid-ocean ridges, the longest mountain chains on Earth, rise thousands of meters above abyssal basins. As magma extrudes along these divergent boundaries, new seafloor forms, carrying continents away from rift zones. The Atlantic Ocean grew wider as Africa and South America drifted apart. In the Indian Ocean, the Reunion hotspot created the Mascarene Plateau, and later the volcanic islands of Mauritius and Reunion. On human time scales, eruptions can trigger climate perturbations, volcanic winters that cool the planet by reflecting sunlight. Tambra's 1815 eruption ushered in the year without a summer, causing frost in July and famine across the northern hemisphere. Yet these same ash and aerosol injections accelerate silicate weathering over centuries, drawing down atmospheric carbon dioxide and helping stabilize Earth's climate over geologic time. In landscapes long abandoned after eruptions, ecological succession unfolds with remarkable regularity. Pioneer species fireweed, alder, lupin flourish in the open ground, fixing nitrogen and shading soils. Birds disperse seeds, while rodents and insects foster microbial diversity. Within generations, mixed woodlands emerge, their mature canopies sheltering understory communities of fungi, invertebrates, and small mammals. Cultures settled around volcanoes have balanced risk with reward for millennia. The fertile slopes of Mt. Etna support rich orchards of citrus, grapes, and olives. In the Andes, communities terrace steep volcanic valleys to grow potatoes and quinoa. In Japan, farmers plant rice paddies at the base of Mt. Fuji, careful to tap spring-fed canals once the ash springs clear. Rituals and myths often honor volcanic deities. Peel in Hawaii, Pachamama in the Andes, and Kagutsuchi in Japan. Modern monitoring networks, seismic arrays, GPS stations, and gas spectrometers track magma movement beneath active volcanoes. Early warning systems in Iceland detected the 2010 Eyjafjallajökull eruption, averting aviation disasters by grounding flights before ash reached flight levels. Japan's sophisticated radar and vent-opening sensors now provide minutes of lead time for evacuation, saving countless lives. Geotourism turns volcanic landscapes into living laboratories. Travelers hike the sulfur-stained slopes of Mount Bromo in Indonesia, explore lava tubes beneath the Big Island of Hawaii, and witness molten lava lakes in East Africa's Rift Valley. National parks like Mount Rainier and Volcanoes in Hawaii protect both natural beauty and the geologic processes that continue to shape our planet. Volcanoes will continue to link destruction and creativity as long as Earth's mantle remains molten. In the next millennium, super-eruptions may reshape continents once more, and mid-ocean ridges will continue to forge new crust beneath the waves. Humanity's challenge is to respect this dynamism by planning resilient infrastructure, harnessing geothermal power, and preserving volcanic soils. Ultimately, volcanoes remind us of Earth's resilience and fragility. They can bury cities in ash or raise forests, but they also build mountains, feed rivers with mineral-rich sediments, and nurture the soils that sustain civilizations. Each eruption is a reset button, clearing the old to make way for new beginnings. In their dual nature as destroyers and creators, volcanoes embody the perpetual dance of chaos and order at Earth's fiery core, an eternal cycle that shapes continents and sustains life. What it means for us today. In a world cast into perpetual twilight by volcanic ash, we witness the raw fragility of human civilization. Modern society rests atop intricate networks, global supply chains, just-in-time production, centralized energy grids that assume uninterrupted flows of goods, data, and power. A single ash cloud halting air travel triggers ripples through finance, food, and health sectors. A few days of field-buried crops can set off months of famine and unrest. Our electricity, water, and communication systems are designed for stability, not for precipitation of razor-sharp ash that corrodes electronics and clogs intake valves. The instant collapse of these lifelines underlines a profound truth. Complexity without redundancy is brittle. We build towering skyscrapers, bridging continents with fiber-optic cables, yet a thin veil of volcanic glass can halt cranes, darken cities, and silence conversations. This scenario teaches us that our greatest strengths, interconnectedness, efficiency, specialization, can become our deepest vulnerabilities when the environment itself asserts its power. The lesson is stark. To survive, we must recognize that our systems, however advanced, are only as resilient as their weakest link. Yet within this portrait of fragility lies a testament to resilience. Humanity has endured centuries of natural upheavals, ice ages, floods, droughts, pandemics, and emerged stronger each time. When ash-darkened skies choked medieval Europe after Tambra's blast, communities adapted by embracing alternative crops, reorganizing grain stores, and sharing scarce resources across regions. In the wake of Toba's super-eruption, early humans found refuge in equatorial microclimates, diversified their diets, and refined tools to exploit new niches. Today, we mirror that ingenuity when engineers retrofit power plants with ash-resistant filters, agronomists breed low-light-tolerant wheat, and communities install microgrids powered by solar domes rising above the ash blanket. From makeshift masks sewn in basements to drone fleets scouting for clear corridors, our ability to innovate under pressure reminds us that resilience emerges not from denial of risk, but from creativity in the face of it. The thin balance between survival and collapse becomes evident in cascading failures. One broken valve can flood a pumping station. One failed harvest can empty a city's granaries. Interdependencies amplify local disruptions into global crises. When volcanic ash darkens airports in Europe, manufacturing plants in Asia idle for lack of parts, supermarkets in Africa run short of staples, and power plants in North America derate to protect turbines. These domino effects reveal how no nation stands alone. Modern resilience demands cooperation across borders. Sharing weather forecasts, coordinating relief flights, and jointly financing emergency food reserves become acts of survival. The challenge lies in forging trust and frameworks that transcend politics, creating a safety net that catches everyone when individual nets fray. To navigate this precarious equilibrium, we must build redundancy into our systems. Multiplying food sources, urban farms, vertical greenhouses, greenhouse troughs and tunnels softens the blow of field-buried crops. Decentralizing energy through solar microgrids, community wind turbines, and local battery banks ensures that one ash-clogged power line does not plunge entire regions into darkness. Diversifying transportation with rail corridors less sensitive to ash and amphibious buses capable of fording ash-clogged streets keeps people and goods moving. Digital communication must leverage high-altitude balloons and mesh networks that bypass ash-interfered satellites. Together, these redundancies create multiple lifelines, preventing single-point failures from spiraling into systemic collapse. Resilience also grows from social capital. In every disaster, communities that share resources, distribute risk, and maintain open lines of communication fare better. Local barter networks swap stored grains for preserved meat. Neighborhood brigades clear ash from fire hydrants and water pumps. Volunteer medics treat respiratory ailments in doorways under makeshift canopies. These grassroots responses complement national and international aid, providing rapid relief that bureaucracies cannot match. Cultivating social cohesion through regular community drills, shared emergency plans, and inclusive decision-making imbues resilience with human strength. In the age of ash, the spirit of collective responsibility becomes as vital as any concrete wall or steel beam. Yet resilience does not mean invulnerability. Volcanoes remind us that Earth's forces dwarf our technologies. Early warning systems can detect seismic unrest and gas emissions, but predicting the exact timing and magnitude of a super-eruption remains beyond our current capabilities. We can model ash dispersion in real time, forecast crop shortfalls, and pre-position relief supplies, but only up to the limits of our imagination and preparedness. Accepting this humility, we invest in continuous monitoring of volcanic activity, maintain flexible supply chains capable of rapid rerouting, and embed scenario training into every level of governance and industry. Preparedness becomes a culture where routine operations include risk assessments, safety margins, and contingency drills. The challenge spans generational horizons. While modern urbanites may never see skies darkened by weeks of ash, past societies lived those centuries. They carved out survival by heeding the lessons of their ancestors, memorizing weather patterns, storing seeds in underground caches, and passing down oral histories of famine and revival. We must preserve and expand this cultural memory. Educational programs should teach both the science of volcanology and the craft of survival. How to forage for ash-tolerant tubers, how to purify water of fluorides, how to craft shelters that filter air. Museums, archives, and community centers can house artifacts from past eruptions and simulations that train new generations to respond. At the same time, we must guard against complacency born of success. A century without a major eruption can lull societies into false security. Infrastructure ages without maintenance for ash resistance. Emergency stockpiles deplete. Laws enabling rapid response lapse. When the next cataclysm strikes, decisions delayed by political inertia or budget constraints cost lives. Recognizing our propensity for forgetting, we institutionalize volcanic winter preparedness as an evergreen priority funding research, retaining skilled personnel and regularly updating protocols. Insurance models must internalize the risk of ashfall, encouraging businesses and homeowners to invest in protective measures rather than gamble on perpetual calm. The scenario also compels us to re-examine our relationship with the environment. Human activities, deforestation, greenhouse gas emissions, groundwater depletion alter climate and geology in ways that can exacerbate volcanic impacts. Warming polar regions destabilize permafrost, releasing methane in pulses. Shifting sea levels change pressure on volcanic calderas. Intense storms erode volcanic slopes, priming them for layers. In the age of ash, climate mitigation and volcano risk management become intertwined, reducing carbon emissions, restoring wetlands to buffer floods, and reforesting volcanic soils all contribute to a more resilient planet. Ultimately, this narrative of ash-darkened skies is a parable of balance. We stand at the interface of human ambition and geological force, a tension that shapes our past, defines our present, and will determine our future. Our cities rise upon volcanic foundations. Our soils owe their fertility to millennia of eruptions. Our economies thrive on minerals concentrated by magma. Yet the same processes that yield gold and fertile fields can obliterate homes and choke economies. In this paradox lies our greatest lesson. Power begets peril, and vulnerability sows opportunity for courage and innovation. As we gaze skyward in the imagining of ash clouds obscuring the sun, we find a mirror held to our own systems. How will our global civilization fare when the sun's rays dim? Will we scramble into darkness, hoarding resources and succumbing to panic? Or will we adapt, swiftly sharing knowledge, deploying distributed technologies, and reaffirming collective bonds? The answer rests in choices we make today, investing in redundancy, strengthening social fabrics, preserving cultural memory, and rebalancing our impact on Earth's dynamic systems. In the end, what it means for us today is both a warning and a promise. The fragility of our interconnected world demands prudence. The resilience of human ingenuity offers hope. By embracing the lessons of ash-laden centuries through preparation, cooperation, and respect for the thin boundary between collapse and continuity, we can ensure that, even when skies darken, the spark of civilization endures and flickers back into light. Conclusion. In the quiet aftermath of volcanic ash, we glimpse both the fragility and tenacity of our world. When skies darken and the sun retreats behind curtains of glassy dust, every unfiltered breath becomes a reminder of nature's power to reshape life on Earth. Crops falter, rivers clog, and familiar rhythms pause under a mantle of ash. Cities fall silent, their streets buried beneath gray drifts. In such moments, systems we take for granted, transport, food supplies, power grids, are laid bare as precarious constructions atop a living planet. Yet amid the stillness of ashen fields, life finds a way. Microbes colonize bare rock, forging the first grains of fertile soil. Pioneering plants push through dusty crusts, their roots knitting together the ashes of devastation. Forests re-emerge, birds return, and the cascade of renewal unfolds in patient centuries. Human societies, too, adapt with ingenuity. Sealed habitats that trap light and heat, greenhouses harnessing every photon, renewable microgrids that power communities through pitch-black days. We learn to build redundancy, to diversify crops, to share information and resources across borders. What if volcanoes covered the Earth in ash? The question illuminates a truth we often overlook. Our civilization sits at a delicate balance, poised between survival and collapse. By studying past eruptions, Tambra's year without a summer, Toba's ancient winter, Laki's sulfur haze, we learn the value of preparedness, cooperation, and humility. We see that resilience is forged not in certainty, but in response to uncertainty, that hope can kindle even in deepest gloom. As you drift into sleep, carry this vision of ashen twilight and slow renewal with you. Let it remind you of our planet as fiery heart and of humanity's capacity to endure. In every waking hour and every restful night, may we honor both the power that can silence the sun and the creativity that brings it back.